Deep within forgotten ruins, whispers of impossible truths echo through stone. Technology, ancient, baffling, almost mythical, awaits rediscovery. These are the tools that defy history, creations that stand like timeless puzzles, challenging our modern minds. From the precision-cut stones of Puma Punku, sharp enough to bewilder today's engineers, to the mysterious Antikythera Mechanism, a device so advanced it shatters our understanding of ancient capabilities. Each discovery rewrites history, leaving scientists stunned and speechless. Who forged these wonders? How could civilizations lost to time produce marvels that we, with all our technology, still can't explain? Ancient technology refers to tools, techniques, and innovations developed by early human civilizations thousands of years ago. These technologies were groundbreaking for their time and often laid the foundation for more advanced developments in later eras. Typically, ancient technologies date back to periods before the Middle Ages, encompassing inventions from prehistoric times through classical antiquity. One defining characteristic of ancient technology is its reliance on basic materials readily available in nature, such as stone, wood, clay, and early metals. These technologies often required significant human labor and ingenuity to create and operate. Examples include the wheel, early writing systems, basic metallurgy, and simple machines like levers and pulleys. Ancient technologies also tend to address fundamental human needs and challenges. This includes innovations in agriculture, construction, warfare, and daily life. The irrigation systems of Mesopotamia, the architectural marvels of ancient Egypt, and the road networks of the Roman Empire all exemplify the scope and impact of ancient technological achievements. Importantly, many ancient technologies demonstrate remarkable sophistication despite limited scientific understanding. The precision of ancient astronomical calculations, the durability of Roman concrete, and the complexity of early mechanical computers like the Antikythera Mechanism continue to impress modern experts, showcasing the ingenuity of our ancestors. Ancient technologies continue to perplex us for several reasons. Many of these innovations were created by civilizations that left behind limited written records, making it challenging to understand their methods and thought processes. The knowledge and skills required to create these marvels were often lost over time due to societal collapses, invasions, or natural disasters. Some ancient technologies demonstrate a level of sophistication that seems to surpass the perceived capabilities of their time. The precision and scale of structures like the Egyptian pyramids or the intricate Roman concrete used in structures that have survived for millennia raise questions about the tools and techniques employed. These achievements challenge our assumptions about the capabilities of ancient peoples and the linear progression of technological advancement. Furthermore, the purpose of certain ancient technologies remains elusive. The Antikythera Mechanism, an ancient Greek analog computer used to predict astronomical positions, is a prime example. Its complexity and precision were unmatched for centuries after its creation, leaving historians and scientists puzzled about its origins and the extent of ancient Greek technological prowess. The mystery surrounding these ancient technologies also stems from our incomplete understanding of the cultural, religious, and practical contexts in which they were developed. As we continue to uncover new archaeological evidence and apply modern scientific analysis to ancient artifacts, we gain new insights into these enigmatic technologies, slowly unraveling their secrets while marveling at the ingenuity of our ancestors. Scientists approach the study of unexplained ancient technologies with a combination of rigorous methodology and open-minded curiosity. They employ a multidisciplinary approach, drawing on expertise from fields such as archaeology, engineering, materials science, and history to unravel the mysteries of these advanced creations from the past. One key aspect of their approach is the use of modern technology to analyze ancient artifacts. Advanced imaging techniques, such as computed tomography and laser scanning, allow researchers to examine the internal structures and minute details of objects without causing damage. Chemical analysis helps determine the composition of materials used, providing clues about their origin and manufacturing processes. Experimental archaeology plays a crucial role in understanding ancient technologies. Scientists attempt to recreate these technologies using tools and materials available in the past, gaining insights into the skills and knowledge required by ancient craftsmen. This hands-on approach often leads to new hypotheses and a deeper appreciation of the ingenuity of our ancestors. Collaboration with local communities and indigenous knowledge holders is also vital. Traditional knowledge passed down through generations can offer valuable perspectives and contextual information that might not be apparent from physical evidence alone. By combining scientific methods with cultural insights, researchers can develop a more comprehensive understanding of unexplained ancient technologies and their significance in past societies. Interdisciplinary research is crucial in unraveling the mysteries of the universe. As we delve deeper into the cosmos, we find that the boundaries between traditional scientific disciplines blur. Astronomers work alongside physicists to understand the fundamental forces at play in celestial bodies. Chemists contribute their expertise to analyze the composition of distant planets and stars. Biologists join the quest to search for signs of life beyond Earth. This collaborative approach allows scientists to tackle complex questions from multiple angles. For instance, the study of exoplanets requires knowledge from astronomy, geology, and atmospheric science. By combining these diverse perspectives, researchers can build a more comprehensive picture of these distant worlds and their potential habitability. Interdisciplinary research also drives technological innovation. Engineers and computer scientists develop cutting-edge instruments and data analysis techniques that enable astronomers to observe the universe in unprecedented detail. This synergy between fields has led to breakthroughs such as the detection of gravitational waves, which required expertise in physics, astronomy, and advanced computational methods. Moreover, the insights gained from cosmic exploration often have unexpected applications in other areas of science and technology. For example, research into dark matter has influenced particle physics experiments on Earth, while studies of stellar nucleosynthesis have enhanced our understanding of nuclear reactions. This cross-pollination of ideas demonstrates the far-reaching impact of interdisciplinary collaboration in advancing our knowledge of the universe and its mysteries. Modern technology has revolutionized our understanding of ancient technologies, allowing us to peer into the past with unprecedented clarity. Advanced imaging techniques, such as computed tomography and multispectral imaging, have enabled researchers to examine artifacts without causing damage. These methods reveal hidden details, internal structures, and even faded inscriptions that were previously invisible to the naked eye. Sophisticated chemical analysis tools now provide insights into the composition of ancient materials, helping us understand how they were sourced, processed, and used. For instance, mass spectrometry can identify trace elements in metals, shedding light on ancient metallurgy techniques and trade routes. DNA analysis of organic materials found in archaeological sites offers clues about the plants and animals our ancestors used in their daily lives. Digital reconstruction and three-dimensional modeling have breathed new life into ancient ruins and fragmented artifacts. By combining archaeological data with computer simulations, researchers can visualize how ancient structures might have looked and functioned. This technology has been particularly valuable in studying architectural marvels like the pyramids of Egypt or the aqueducts of Rome. Satellite imagery and remote sensing technologies have transformed the field of archaeology, allowing researchers to discover new sites and map vast areas without extensive ground surveys. These tools have revealed previously unknown cities, roads, and monuments hidden beneath dense vegetation or desert sands. By combining these modern methods with traditional archaeological techniques, we continue to uncover the ingenuity of our ancestors and gain a deeper appreciation for their technological achievements. The Antikythera Mechanism is an ancient Greek device that has astounded scientists and historians since its discovery in 1901. This remarkable artifact is often described as the world's first analog computer, dating back over 2,000 years to around 150 to 100 BCE. Found in a shipwreck off the coast of the Greek island Antikythera, this complex bronze mechanism consists of dozens of gears and wheels working in harmony. Its purpose was to predict astronomical positions and eclipses for calendrical and astrological purposes, as well as to track the 4-year cycle of athletic games similar to the ancient Olympic Games. What makes the Antikythera mechanism truly extraordinary is its level of sophistication, which was unmatched for at least 1,000 years after its creation. It could calculate the positions of celestial bodies with remarkable accuracy, considering the knowledge available at the time. The device even accounted for the irregular orbit of the Moon, demonstrating an advanced understanding of celestial mechanics. The discovery of the Antikythera mechanism has forced historians to reevaluate their understanding of ancient Greek technology and scientific knowledge. It serves as a testament to the ingenuity and intellectual achievements of our ancestors, reminding us that the path of human innovation is not always a straight line of progress. The Antikythera mechanism was discovered in 1901 off the coast of the Greek island of Antikythera. A group of sponge divers stumbled upon the wreckage of an ancient Roman cargo ship while searching for sponges in the Aegean Sea. The divers found numerous artifacts, including statues, pottery, and coins, but among these treasures was a mysterious lump of corroded bronze that would later be recognized as one of the most significant archaeological finds of the 20th century. Initially overlooked, this encrusted object was eventually identified as an intricate mechanical device. The true nature and complexity of the Antikythera mechanism only began to emerge after decades of careful study and analysis. As researchers peered into its structure using advanced imaging techniques, they uncovered a sophisticated ancient Greek astronomical calculator. The shipwreck itself is believed to date back to around 70 to 60 BCE, suggesting that the Antikythera mechanism is even older. This remarkable discovery has reshaped our understanding of ancient Greek technology and scientific knowledge, revealing a level of mechanical sophistication that was previously thought impossible for that era. The story of the Antikythera mechanism serves as a powerful reminder that groundbreaking discoveries can emerge from unexpected places, challenging our preconceptions about the capabilities of ancient civilizations and the evolution of human knowledge. The Antikythera mechanism, an ancient Greek analog computer, is estimated to be over 2,000 years old. This remarkable device was discovered in a shipwreck off the coast of the Greek island Antikythera in 1901. After extensive research and analysis, scientists have determined that it was likely constructed between 100 and 200 BCE, making it date back to the 2nd century BCE. This ancient technological marvel predates other comparable devices by more than a millennium. Its complexity and sophistication have astounded researchers, challenging our understanding of ancient Greek technology and astronomical knowledge. The mechanism consists of a complex system of gears and dials that could predict astronomical positions and eclipses for calendar and astrological purposes. The age of the Antikythera mechanism places it in the Hellenistic period, a time of great scientific and cultural advancement in the ancient Mediterranean world. Its creation coincides with the era of influential Greek mathematicians and astronomers like Hipparchus, who made significant contributions to trigonometry and the understanding of celestial movements. The discovery and dating of this ancient computer have revolutionized our perception of technological capabilities in the ancient world. It serves as a testament to the ingenuity and scientific understanding of our ancestors, highlighting the advanced state of Greek astronomy and engineering over 2 millennia ago. The Antikythera mechanism, an ancient Greek astronomical calculator, consists of several intricate components that work together to track celestial movements. At its core are a series of bronze gears precisely crafted to mesh and rotate in complex patterns. These gears, numbering at least 30, form the heart of the device's computational power. The mechanism features multiple dials on both its front and back faces. The largest dial on the front represents the zodiac and the Egyptian calendar, allowing users to correlate astronomical events with dates. Smaller dials track the movements of the 5 planets known to the ancient Greeks: Mercury, Venus, Mars, Jupiter, and Saturn. On the back of the device, we find dials that predict lunar phases and eclipses. One particularly fascinating component is the spiral dial that follows the 19-year Metonic cycle, which aligns the lunar and solar calendars. This feature allowed ancient astronomers to predict when important religious festivals would occur. The entire mechanism was housed in a wooden case, now long decayed, with doors that could be opened to reveal the intricate workings within. Bronze plates, some of which survive, were engraved with instructions and astronomical information, serving as an ancient user manual for this remarkably sophisticated device. The Antikythera Mechanism stands as a testament to the ingenuity and technological prowess of ancient Greek civilization, far surpassing what many historians previously believed possible for that era. This intricate device, often called the world's first analog computer, was discovered in a shipwreck off the Greek island of Antikythera in 1901. Its complexity has forced scholars to re-evaluate their assumptions about ancient technological capabilities. The mechanism's sophistication lies in its intricate system of gears and dials, which were used to predict astronomical positions and eclipses with remarkable accuracy. This level of precision in metalworking and astronomical knowledge was thought to be beyond the reach of ancient Greek technology. The device's ability to track the movements of celestial bodies and even account for leap years demonstrates a deep understanding of mathematics and astronomy that was not thought to exist until much later in history. Furthermore, the Antikythera Mechanism's construction required a level of miniaturization and engineering skill that was previously unattributed to ancient civilizations. The compact nature of the device, with its tightly packed gears and mechanisms, suggests a level of craftsmanship that challenges our understanding of ancient manufacturing techniques. This complexity raises questions about the existence of other advanced technologies from this period that may have been lost to time. The discovery of the Antikythera Mechanism has led to a reassessment of the technological capabilities of ancient Greek society. It suggests that there may have been a more advanced technological tradition in the ancient world than previously recognized, prompting researchers to look for evidence of similar devices or knowledge in other archaeological contexts. This enigmatic artifact continues to challenge our perceptions and expand our understanding of ancient Greek technological achievements. The Antikythera Mechanism stands as one of the most remarkable technological artifacts from the ancient world. This sophisticated device, discovered in a shipwreck off the coast of the Greek island Antikythera, served as an ancient analog computer designed to predict astronomical positions and eclipses. Dating back to around 100 to 200 years before the Common Era, this complex mechanism used a system of intricate gears to track the movements of celestial bodies. It could calculate the positions of the Sun, Moon, and likely the 5 planets known to the ancient Greeks: Mercury, Venus, Mars, Jupiter, and Saturn. The device also functioned as an advanced calendar, capable of following the 4-year cycle of athletic games, including the ancient Olympic Games. Additionally, it could predict solar and lunar eclipses with impressive accuracy, demonstrating the advanced astronomical knowledge of its creators. The Antikythera Mechanism reveals the remarkable scientific and engineering capabilities of ancient Greek civilization. Its discovery has fundamentally altered our understanding of ancient technology and the depth of astronomical knowledge in the classical world. The Antikythera Mechanism stands as a testament to the ingenuity of ancient Greek astronomers and engineers. This remarkable device, often called the world's first analog computer, demonstrated an astonishing level of accuracy in its astronomical calculations. Studies have shown that the mechanism could predict the positions of celestial bodies, solar and lunar eclipses, and even the timing of ancient Olympic Games with impressive precision. Its gear system allowed it to account for the irregular orbits of the Moon and known planets, reflecting a sophisticated understanding of celestial mechanics. For lunar calculations, the device incorporated the Metonic cycle, a 19-year period after which the phases of the Moon repeat on the same days of the year. This feature allowed for accurate long-term predictions of lunar events. The solar calculations were based on the Callipic cycle, which provided an even more refined method for determining the length of the solar year. While not perfect by modern standards, the Antikythera mechanism's accuracy was remarkable for its time, typically achieving precision within a day or two over long periods. This level of sophistication in ancient timekeeping and astronomical prediction continues to astound researchers, offering insights into the advanced scientific knowledge of ancient civilizations. The Antikythera mechanism, an ancient Greek astronomical calculator, can be compared to several modern devices and systems. In terms of function, it shares similarities with contemporary planetariums, which model the movements of celestial bodies. These sophisticated projection systems allow us to observe and predict astronomical events, much like the Antikythera mechanism did for its creators over 2,000 years ago. From a computational standpoint, the mechanism bears resemblance to modern analog computers. While not electronic, its intricate system of gears and dials performed complex calculations, mirroring the way analog computers use continuous physical phenomena to model and solve problems. This ancient device showcases an early form of mechanical computation that laid the groundwork for future calculating machines. In the realm of timekeeping and celestial tracking, we can draw parallels between the Antikythera mechanism and contemporary atomic clocks, coupled with advanced astronomical software. These modern systems provide incredibly precise measurements of time and can accurately predict celestial events, eclipses, and planetary positions, much like the ancient mechanism aimed to do within the constraints of its era's technology. Lastly, we can compare the Antikythera mechanism to modern smartwatches with astronomical complications. These wearable devices can display lunar phases, track planetary positions, and even predict solar and lunar eclipses, echoing the multifaceted functionality of their ancient predecessor in a compact, electronic form. The Baghdad Battery is an intriguing archaeological artifact that has sparked much debate and speculation among historians and scientists. Discovered in 1938 near Baghdad, Iraq, this curious object consists of a clay jar containing a copper cylinder and an iron rod. The jar measures about 5 inches in height and dates back to the Parthian period, approximately 2,000 years ago. What makes the Baghdad Battery so fascinating is its potential to have functioned as an ancient electrical device. When filled with an acidic liquid, such as vinegar or wine, the copper and iron components could theoretically generate a small electrical charge. This has led some researchers to suggest that ancient civilizations might have had knowledge of electricity long before its official discovery in modern times. However, the true purpose of the Baghdad Battery remains a subject of controversy. While some experts argue it could have been used for electroplating or as a primitive form of pain relief, others contend it may have simply been a storage vessel for sacred scrolls. The lack of any written records or similar devices from the same period adds to the mystery surrounding its function. Despite the uncertainty, the Baghdad Battery continues to captivate our imagination, challenging our assumptions about ancient technological capabilities and reminding us that there is still much to learn about the ingenuity of our ancestors. It serves as a testament to the complexity of ancient civilizations and the potential for groundbreaking discoveries that can reshape our understanding of history. The Baghdad Battery was unearthed in 1938 during excavations near the Iraqi capital. This intriguing artifact, also known as the Parthian Battery, was found in the village of Kujut Rabu, just outside Baghdad. The discovery was made by German archaeologist Wilhelm König, who was working at the National Museum of Iraq at the time. This ancient device consists of a clay jar containing a copper cylinder and an iron rod. Its unusual construction immediately sparked curiosity among researchers. The artifact dates back to the Parthian period, approximately 2,000 years ago, though some experts suggest it could be even older. The purpose of this mysterious object remains a subject of debate among historians and scientists. Some theorize it might have been used for electroplating or as a primitive form of electrical storage, while others argue it could have had religious or medicinal purposes. Despite extensive study, the true function of the Baghdad battery continues to elude definitive explanation. Its discovery has led to fascinating discussions about the level of scientific knowledge possessed by ancient civilizations, challenging our understanding of technological development throughout history. The Baghdad battery serves as a reminder that our ancestors may have been more advanced than we previously thought, leaving us with tantalizing questions about lost knowledge and forgotten innovations. The Baghdad battery, an intriguing archaeological artifact discovered in Iraq, consists of several key components. The outer vessel is a clay jar about the size of a modern teapot. Inside this clay container sits a copper cylinder, which forms the central element of the device. Within the copper cylinder, archaeologists found an iron rod. These metal components were separated by a layer of asphalt, which acted as a sealant and insulator. The exact purpose of this ancient device remains a subject of debate among historians and scientists. Some researchers suggest it might have been used for electroplating or as a primitive form of electrical storage. Others propose more mundane uses, such as storing sacred scrolls or simply as a container for valuable items. The materials used in the Baghdad battery are significant because they are all naturally occurring and would have been available to ancient civilizations. Copper and iron are metals that can be found in their native form or extracted from ores. Clay and asphalt are abundant in the region where the artifact was discovered. This combination of materials, arranged in a specific configuration, has led to fascinating speculation about the technological capabilities of ancient societies. While the true function of the Baghdad battery remains uncertain, its composition continues to spark curiosity and inspire research into the ingenuity of our ancestors. The device serves as a reminder that ancient civilizations possessed sophisticated knowledge of materials and their properties, challenging our assumptions about the development of technology throughout human history. The Baghdad battery, also known as the Parthian battery, is an intriguing archaeological artifact that continues to spark debate among historians and scientists. This mysterious object is believed to date back to the Parthian period, which lasted from approximately 250 years before the Common Era to 224 years into the Common Era. Most experts estimate that the Baghdad battery was created sometime between 250 years before the Common Era and 650 years into the Common Era. This wide range of dates reflects the uncertainty surrounding the artifact's origins and purpose. The battery was discovered in 1938 during excavations near Baghdad, Iraq. It consists of a clay jar containing a copper cylinder and an iron rod, which some researchers believe could have been used to generate an electric current when filled with an acidic solution. The age of the Baghdad battery is particularly significant because if it indeed functioned as an electrical device, it would predate the official discovery of electricity by more than 1,000 years. This possibility has led to numerous theories about the technological capabilities of ancient civilizations and their potential understanding of electrical phenomena. However, it is important to note that the true purpose and functionality of the Baghdad battery remain subjects of ongoing scientific debate. Some scholars argue that it may have been used for electroplating or as a galvanic cell, while others suggest it could have served a completely different, non-electrical purpose altogether. The Baghdad battery, an ancient artifact discovered in Iraq, has sparked numerous theories about its potential purpose. This clay pot, containing a copper cylinder and an iron rod, dates back to the Parthian period, around 2,000 years ago. Some researchers propose that it may have functioned as a primitive galvanic cell, capable of producing a small electric current when filled with an acidic liquid like vinegar or wine. Capable of producing a small electric current when filled with an acidic liquid like vinegar or wine. One intriguing theory suggests that the Baghdad battery could have been used for electroplating, a process of coating objects with a thin layer of metal using electricity. This technique might have been employed to gild silver objects with gold, creating valuable and impressive artifacts. However, no electroplated items from that era have been found to support this hypothesis. Another speculation is that the device served a medical purpose. Some theorists propose it could have been used to administer electric shocks for pain relief or other therapeutic applications. This idea draws parallels with later practices of using electricity in medicine, though it remains speculative for the time period in question. Skeptics argue that the Baghdad battery might not have been a battery at all. They suggest it could have been a simple storage vessel for sacred scrolls or valuable documents. The internal components, they claim, might have served as protective elements or had religious significance rather than electrical functionality. Despite the various theories, the true purpose of the Baghdad battery remains a subject of debate among historians and archaeologists. The Baghdad battery, discovered in Iraq and dating back to the Parthian period, has intrigued scientists and historians for decades. This ancient artifact consists of a clay jar containing a copper cylinder and an iron rod, which some researchers believe could have functioned as a primitive galvanic cell. To generate electricity, the Baghdad battery might have used a principle similar to modern batteries. The copper cylinder and iron rod could have acted as electrodes, while an acidic solution, possibly vinegar or wine, could have served as an electrolyte. When these components interact, they create a chemical reaction that produces a small electric current. The potential voltage generated by such a device would have been relatively low, estimated at around 1 volt. This output would have been insufficient for most practical applications we associate with electricity today. However, it could have been enough for some simple tasks, such as electroplating metal objects, or possibly for medicinal purposes. It is important to note that the true purpose of the Baghdad battery remains a subject of debate among experts. Some scholars argue that it may not have been intended as an electrical device at all, suggesting alternative uses such as storage for sacred scrolls or simply as a container for valuable items. The mystery surrounding this ancient artifact continues to fuel scientific curiosity and historical research. Scientists and historians have conducted several experiments to explore the potential capabilities of the Baghdad battery, an ancient artifact discovered in Iraq that some believe could have been an early form of electrical device. These tests have aimed to determine whether the object could indeed generate an electric current and for what purpose it might have been used. One notable experiment was carried out by Dr. Arne Eggebrecht, who created a replica of the Baghdad battery using materials available in ancient Mesopotamia. He filled the clay jar with an acidic liquid, such as vinegar or wine, and found that it could produce a small electric current of around half a volt. This amount of electricity would have been sufficient for electroplating small objects with gold. Other researchers have replicated these findings, demonstrating that the device could theoretically generate electricity. However, they have also noted that the current produced would be relatively weak and short-lived, raising questions about its practical applications in ancient times. Some experimenters have explored alternative theories, such as the possibility that the Baghdad battery was used for medicinal purposes. They have tested whether the device could deliver a mild electric shock, which some ancient cultures believed had healing properties. While these experiments have shown that such an application was possible, there is no conclusive evidence that this was the intended use of the artifact. The Baghdad battery, discovered in Iraq in 1938, presents an intriguing puzzle for historians of science and technology. This artifact, dating back to the Parthian period between 250 before the Common Era and 224 of the Common Era, consists of a clay jar containing a copper cylinder and an iron rod. When filled with an acidic liquid like vinegar, it could potentially generate a small electrical charge. This discovery challenges our conventional understanding of when humans first harnessed electricity. Traditionally, we attribute the birth of electrical science to the 18th century, with key figures like Benjamin Franklin and Alessandro Volta. However, the Baghdad battery suggests that some form of electrical technology might have existed over 2,000 years ago. If the Baghdad battery indeed functioned as an electrical device, it would imply that ancient civilizations had a rudimentary understanding of electrochemical principles long before the formal development of electrical theory. This possibility forces us to reconsider the timeline of technological progress and the potential sophistication of ancient societies. However, it is important to note that the purpose of the Baghdad battery remains debated among scholars. Some suggest it might have been used for electroplating or for medicinal purposes, while others argue it could have been a simple storage vessel. Regardless of its true function, the Baghdad battery continues to spark curiosity and challenge our assumptions about the history of electrical knowledge. Roman concrete stands out as a remarkable achievement of ancient engineering. This durable material has withstood the test of time, lasting for thousands of years, while modern concrete often deteriorates within decades. The secret lies in its unique composition and the chemical reactions that occur within it. The Romans created their concrete using a mixture of volcanic ash, lime, seawater, and rock fragments. When combined, these ingredients form a substance called calcium aluminum silicate hydrate. This compound continues to strengthen the concrete over time, particularly when exposed to seawater. As waves crash against Roman structures, they trigger a reaction that fills tiny cracks with new minerals, effectively allowing the concrete to heal itself. Another key factor in Roman concrete's longevity is its ability to resist corrosion. Modern concrete often contains steel reinforcements that can rust and expand, causing cracks and structural weakness. Roman concrete, however, relies on its inherent strength and does not require such reinforcements, eliminating this potential point of failure. The endurance of Roman concrete is evident in structures like the Pantheon in Rome, which has stood for nearly 2,000 years. This ancient technology has sparked renewed interest among modern researchers seeking to develop more sustainable and long-lasting building materials for the future. Roman concrete has proven to be remarkably durable, often surpassing modern concrete in longevity. Ancient Roman structures, such as the Pantheon in Rome, have stood for nearly 2,000 years, withstanding the test of time and environmental forces. This impressive durability is largely due to the unique composition of Roman concrete. The secret to Roman concrete's strength lies in its ingredients and curing process. Roman builders used a mixture of volcanic ash, lime, and seawater, which created a chemical reaction that strengthened the concrete over time. This process, known as mineral crystallization, continues for centuries, actually making the concrete stronger as it ages. Modern concrete, while strong and versatile, typically begins to degrade after several decades. It is more prone to cracking and corrosion, especially when exposed to salt water or other harsh environmental conditions. This is partly due to the use of Portland cement, which, while quick-setting and strong, does not have the same self-healing properties as Roman concrete. Recent research into Roman concrete has sparked interest in developing more durable modern concrete mixtures. Scientists are exploring ways to incorporate the beneficial properties of Roman concrete into contemporary building practices, aiming to create structures that can withstand the ravages of time as effectively as their ancient counterparts. Roman concrete, a marvel of ancient engineering, was composed of several key ingredients that contributed to its remarkable durability. The foundation of this material was a mixture of volcanic ash, lime, and seawater. Volcanic ash, particularly from the area around Mount Vesuvius, played a crucial role in the concrete's strength and longevity. The lime used in Roman concrete was created by heating limestone in kilns, producing quicklime. This quicklime was then mixed with water to form slaked lime, a key binding agent in the concrete. The addition of seawater, rather than fresh water, introduced mineral elements that enhanced the concrete's resistance to deterioration. Perhaps the most intriguing aspect of Roman concrete was the inclusion of volcanic rock fragments, known as tuff. These fragments, along with other aggregates like brick and stone rubble, were carefully selected and incorporated into the mixture. The combination of these materials created a chemical reaction that actually strengthened the concrete over time, particularly when exposed to seawater. This unique composition allowed Roman structures to withstand the test of time, with many still standing after 2,000 years. The enduring nature of Roman concrete has puzzled and inspired modern scientists, leading to ongoing research into replicating its remarkable properties for contemporary construction projects. The ancient Romans developed their remarkable concrete through a combination of experimentation, observation, and the fortunate availability of unique volcanic materials. Their discovery was not a single eureka moment, but rather a gradual refinement of techniques over centuries. Roman builders noticed that certain volcanic ash, particularly from the area around Mount Vesuvius, created exceptionally strong and durable mortar when mixed with lime and seawater. This ash, known as pozzolana, contained aluminosilicate minerals that reacted with the lime to form a strong, waterproof binding material. What set Roman concrete apart was its ability to strengthen over time, especially in marine environments. As seawater permeated the concrete, it triggered chemical reactions that formed new minerals, filling in cracks and actually reinforcing the structure. This self-healing property was a happy accident, resulting from the specific mineral composition of their local materials. The Romans refined their concrete formula through trial and error, documenting successful mixtures and techniques. They passed this knowledge down through generations of builders, allowing them to construct increasingly ambitious structures that have withstood the test of time for 2 millennia. The composition of Roman concrete has puzzled scientists and engineers for centuries due to its remarkable durability and longevity. Ancient Roman structures, such as the Pantheon and numerous aqueducts, have withstood the test of time for over 2,000 years, far outlasting modern concrete structures. The mystery surrounding Roman concrete stems from the loss of knowledge about its exact formulation. As the Roman Empire declined, the sophisticated techniques for creating this exceptional building material were gradually forgotten. The original recipes and methods were not systematically recorded or passed down through generations, leaving modern researchers to piece together clues from ancient texts and archaeological evidence. Another factor contributing to the enigma is the complexity of the material itself. Roman concrete is not a simple mixture, but a sophisticated composite that undergoes chemical changes over time. It contains volcanic ash, lime, and seawater, which interact in ways that are still not fully understood. This unique combination of ingredients creates a material that actually strengthens over time, a property that modern concrete lacks. Recent scientific analyses have shed some light on the composition of Roman concrete, revealing the presence of rare minerals that form within the material over centuries. However, the exact proportions of ingredients and the specific techniques used to mix and cure the concrete remain elusive. This ongoing mystery continues to drive research as scientists and engineers seek to unlock the secrets of this ancient marvel and potentially apply its principles to create more durable and sustainable modern building materials. Ancient Roman concrete has proven remarkably durable, with numerous structures still standing after 2 millennia. The Pantheon in Rome stands as one of the most impressive examples. This architectural marvel, completed around 126 CE, boasts the largest unreinforced concrete dome in the world. Its massive structure has withstood earthquakes, wars, and the relentless passage of time, testament to the incredible strength of Roman concrete. Another enduring structure is the Pont du Gard aqueduct in southern France. This three-tiered bridge, constructed in the 1st century CE, carried water over 50 kilometers to the Roman colony of Nemausus. The aqueduct's arches and piers, built with Roman concrete, have remained intact for nearly 2,000 years, showcasing the material's resilience against weathering and erosion. The port of Caesarea Maritima in Israel provides further evidence of Roman concrete's durability in marine environments. Built by Herod the Great around 25 BCE, parts of the harbor structures remain visible both above and below the waterline. The concrete used in these maritime structures has withstood constant exposure to seawater, a feat that modern concrete often struggles to match. These enduring monuments not only serve as reminders of the Roman Empire's architectural prowess, but also continue to intrigue scientists and engineers. The longevity of Roman concrete, particularly in challenging environments, has led to renewed interest in understanding and potentially replicating its unique properties for modern construction applications. Modern scientists have long been fascinated by the durability of Roman concrete, which has withstood the test of time for over 2,000 years. In recent decades, researchers have made significant strides in unraveling the secrets of this ancient building material. They have analyzed samples from Roman structures, studying their chemical composition and microscopic structure to understand what makes them so resilient. One key discovery was the role of volcanic ash in Roman concrete. Scientists found that this material, when mixed with lime and seawater, creates a chemical reaction that strengthens the concrete over time. This process, known as pozzolanic reaction, continues for centuries, actually making the concrete stronger as it ages. Modern attempts to recreate Roman concrete have focused on replicating this unique mix of ingredients and understanding the precise ratios used by ancient builders. Researchers have also investigated the role of seawater in the curing process of Roman concrete. They found that seawater interacts with the volcanic ash and lime mixture to form rare minerals within the concrete matrix. These minerals, such as aluminum tobermorite and philipsite, contribute to the material's strength and resistance to cracking. Scientists are now experimenting with ways to incorporate these minerals into modern concrete formulations. Some engineers and materials scientists are taking these findings and applying them to create more durable and environmentally friendly concrete for modern construction. By incorporating volcanic ash or similar pozzolanic materials and adjusting the curing process, they aim to develop concrete that can better withstand harsh environments and reduce the carbon footprint of construction. While we have not yet fully replicated the exact properties of Roman concrete, these ongoing efforts bring us closer to understanding and recreating this remarkable ancient technology. Roman concrete, renowned for its exceptional durability, could revolutionize modern construction practices if successfully recreated. This ancient material has withstood the test of time, remaining intact for 2 millennia in some cases, even when exposed to harsh marine environments. One of the most promising applications for recreated Roman concrete would be in coastal and marine structures. Seawalls, piers, and offshore platforms could benefit greatly from its resistance to saltwater corrosion. This durability could significantly extend the lifespan of these structures, reducing maintenance costs and improving safety in maritime industries. In urban infrastructure, Roman concrete could be used to build more resilient roads, bridges, and buildings. Its ability to withstand environmental stresses could lead to longer-lasting structures, potentially reducing the frequency of repairs and replacements. This longevity could result in substantial cost savings for governments and taxpayers over time. Additionally, the environmental impact of construction could be reduced by using Roman concrete. Its production process is believed to have a lower carbon footprint compared to modern Portland cement, making it an attractive option for sustainable building practices. As the world seeks to reduce carbon emissions, this ancient technology could play a crucial role in greener construction methods. Damascus steel is a legendary metal known for its distinctive wavy pattern and exceptional strength. This remarkable material was originally created in the Near East, particularly in the city of Damascus, Syria, from which it derives its name. Swordsmiths in this region produced blades of unparalleled quality between the 3rd and 17th centuries. The unique properties of Damascus steel come from its manufacturing process, which involves folding and forge welding multiple layers of different steel alloys. This technique creates a material with a heterogeneous composition, resulting in the characteristic wavy or watery pattern visible on the surface of the blade. This pattern is not merely decorative, but also indicative of the steel's superior qualities. Damascus steel blades were renowned for their sharpness, durability, and flexibility. They could reportedly cut through other swords without losing their edge and even slice through falling silk scarves. The exact technique for creating true Damascus steel was lost over time, and modern attempts to recreate it have not fully replicated its legendary properties. Today, the term Damascus steel is often used to describe pattern-welded steel that mimics the appearance of the original material. While these modern versions can be of high quality, they do not possess the same unique microstructure and properties that made the original Damascus steel so extraordinary. The allure and mystery surrounding this ancient material continue to captivate metallurgists, historians, and blade enthusiasts alike. Damascus steel, renowned for its distinctive wavy pattern, possesses a combination of remarkable properties that have fascinated metallurgists and weapon enthusiasts for centuries. This legendary material exhibits exceptional strength and durability, allowing blades forged from Damascus steel to maintain a sharp edge far longer than ordinary steel. The unique layered structure of Damascus steel, created through a complex folding and forging process, contributes to its superior toughness and resistance to shattering. One of the most intriguing aspects of Damascus steel is its ability to be both hard and flexible simultaneously. This rare combination allows weapons made from this material to absorb impact without breaking, while still retaining their sharpness. The steel's distinctive wavy pattern, known as a water pattern or damask, is not merely decorative, but also indicative of its internal structure, which contributes to its exceptional performance. Recent studies have revealed that Damascus steel contains carbon nanotubes and cementite nanowires, structures that were unknown to ancient metallurgists, but explain many of the material's legendary properties. These microscopic structures enhance the steel's strength and flexibility, allowing it to outperform many modern steel alloys in certain applications. Despite centuries of study, some aspects of traditional Damascus steel production remain a mystery. The exact techniques used by ancient smiths were lost over time, and modern attempts to recreate authentic Damascus steel have met with varying degrees of success. This enigmatic quality only adds to the allure of Damascus steel, making it a subject of ongoing research and admiration in the field of metallurgy. Damascus steel, renowned for its distinctive wavy pattern and exceptional strength, first emerged in the Near East around the 3rd century. This remarkable metal gained its name from the Syrian city of Damascus, a major center for trade and craftsmanship in the medieval period. However, the exact origins of Damascus steel production remain somewhat shrouded in mystery. The earliest confirmed examples of Damascus steel date back to around 250 CE, though some historians suggest its roots may extend even further into antiquity. This innovative steel-making process spread across the Islamic world, reaching its zenith during the 8th to 16th centuries. Damascus steel became highly prized for its durability and sharp edge, making it particularly sought after for crafting superior weapons and tools. Interestingly, the original method for producing true Damascus steel was lost sometime in the 18th century. Modern metallurgists and bladesmiths have attempted to recreate this legendary material, but the exact techniques used by ancient craftsmen remain elusive. The loss of this knowledge adds an element of intrigue to the history of Damascus steel, sparking ongoing research and speculation in the field of metallurgy. The story of Damascus steel serves as a testament to the ingenuity of early metalworkers and the advanced technological achievements of past civilizations. It reminds us that some ancient manufacturing techniques were so sophisticated that they continue to challenge our understanding even in the modern era. The disappearance of true Damascus steel remains one of metallurgy's most intriguing mysteries. This legendary metal, known for its distinctive wavy pattern and exceptional strength, was produced in the Near East from around 800 to 1800 CE. Its sudden vanishing from production has puzzled scientists and historians for centuries. Several factors likely contributed to the loss of this remarkable steel-making technique. One key reason was the exhaustion of the specific ore used in its creation. Damascus steel required a particular type of iron ore, rich in trace elements like vanadium and molybdenum. As these ore sources were depleted, craftsmen found it increasingly difficult to replicate the steel's unique properties. Another crucial factor was the secrecy surrounding the manufacturing process. The exact technique for creating Damascus steel was closely guarded by master craftsmen, often passed down through generations within families. This limited transmission of knowledge made the process vulnerable to loss if the chain of expertise was broken. Political and economic changes in the region also played a role. The shift of trade routes and the decline of certain empires disrupted the complex supply chains and networks of expertise necessary for Damascus steel production. As demand waned and alternative steel-making methods emerged, the incentive to maintain this challenging and resource-intensive process diminished, eventually leading to its complete disappearance. Damascus steel, renowned for its distinctive wavy pattern and exceptional strength, has intrigued metallurgists and historians for centuries. Several theories attempt to explain the lost technique of creating this legendary metal. One prominent idea suggests that the steel contained trace amounts of elements like vanadium, molybdenum, or tungsten, which contributed to the formation of carbon nanotubes and carbide nanowires within the metal structure. These microscopic features might have been responsible for the steel's remarkable properties. Another theory proposes that the secret lay in the specific heat treatment processes used by ancient smiths. This approach may have involved repeatedly heating and cooling the metal at precise temperatures, possibly combined with mechanical working, to achieve the desired crystalline structure. Some researchers believe that the key ingredient was a specific type of iron ore from India, rich in certain impurities that contributed to the steel's unique characteristics. There is also speculation that the legendary qualities of Damascus steel were partly due to the incorporation of organic materials during the forging process. This could have included wood or plant matter, which would have added carbon and other elements to the metal in a controlled manner. The exact combination of materials and techniques likely varied among different smiths and regions, contributing to the mystery surrounding the production method. Regardless of the specific technique, most experts agree that the creation of Damascus steel involved a complex and time-consuming process that required great skill and knowledge passed down through generations of craftsmen. The loss of this technique is often attributed to the exhaustion of the specific ore sources, changes in trade routes, or the disruption of traditional knowledge transmission due to societal changes. Modern metallurgists have been fascinated by the legendary Damascus steel for centuries, striving to unravel its secrets and recreate its unique properties. These craftsmen have employed various techniques and technologies in their quest to replicate this ancient material. One approach involves pattern welding, where different types of steel are forge welded together and then folded and reforged multiple times. This method creates a layered structure that resembles the distinctive wavy patterns of Damascus steel. However, while visually similar, this technique does not truly replicate the microstructure of the original material. Another method focuses on recreating the chemical composition of Damascus steel. Metallurgists have analyzed historical artifacts to determine the elemental makeup of the original steel. They then attempt to reproduce this composition using modern alloys and heat treatment processes. Some have experimented with adding trace elements like vanadium or molybdenum, which may have been present in the ores used by ancient smiths. Advanced microscopy and materials science techniques have also played a crucial role in these efforts. By studying the nanostructure of authentic Damascus steel, researchers have gained insights into the unique carbon nanotube and cementite nanowire formations that contribute to its remarkable properties. This knowledge has informed attempts to create modern steels with similar nanostructures, bringing us closer to truly recreating this legendary material. Damascus steel, renowned for its distinctive wavy pattern and exceptional strength, owes much of its legendary status to the impurities present in its composition. These impurities, far from being detrimental, actually contributed to the steel's remarkable properties. The key impurities found in Damascus steel included trace amounts of tungsten, vanadium, and other elements. These elements, unintentionally introduced during the smelting process, formed microscopic structures within the steel. As the metal was repeatedly folded and forged, these impurities created a complex network of carbides, which are extremely hard particles dispersed throughout the softer steel matrix. This unique microstructure resulted in a blade that was both incredibly sharp and remarkably tough. The carbides provided hardness for maintaining a keen edge, while the softer steel matrix allowed the blade to absorb impacts without shattering. This combination of properties made Damascus steel highly prized for weapons and tools. The presence of these impurities also contributed to the formation of the characteristic wavy pattern known as damascene, which appeared on the surface of the steel when it was etched with acid. This pattern, a result of the distribution of carbides and other impurities, became a hallmark of authentic Damascus steel and added to its mystique and value. Damascus steel, renowned for its distinctive wavy pattern and exceptional strength, represents a fascinating example of lost ancient knowledge. This legendary metal, used in the creation of swords and other weapons, was produced in the Near East from around 300 BC to 1700 AD. Its unique properties, including the ability to maintain a sharp edge and resist shattering, made it highly prized among warriors and collectors. The exact method for creating Damascus steel was lost over time, leaving modern metallurgists and historians puzzled. Despite numerous attempts to recreate the process, the original technique remains elusive. This loss of knowledge occurred gradually, as the craftsmen who held the secrets of Damascus steel production failed to pass on their expertise to subsequent generations. The mystery surrounding Damascus steel serves as a poignant reminder that not all technological advancements are cumulative. Sometimes, valuable knowledge can slip through the cracks of history, leaving future generations to wonder at the achievements of their ancestors. This phenomenon is not unique to Damascus steel. Many other examples of lost ancient technologies exist, from Roman concrete to the Greek fire used in naval warfare. The story of Damascus steel highlights the importance of preserving and documenting knowledge. It also underscores the complex nature of technological progress, where advancements can sometimes lead to the neglect and eventual loss of older, yet still valuable, techniques and technologies. As we continue to unravel the secrets of Damascus steel, we are reminded of the ingenuity of our ancestors and the enduring allure of ancient mysteries. Greek fire was a mysterious and potent incendiary weapon used by the Byzantine Empire from the 7th century onwards. This legendary substance could burn on water and was nearly impossible to extinguish, making it a formidable tool in naval warfare. The exact composition of Greek fire remains unknown to this day, as its formula was a closely guarded state secret. The Byzantines typically deployed Greek fire through specially designed ships equipped with bronze tubes, allowing them to project the flaming liquid onto enemy vessels. This weapon gave the Byzantine navy a significant advantage in battles, particularly in defending Constantinople against Arab sieges. Despite numerous attempts by historians and scientists to recreate Greek fire, its precise ingredients and method of production remain elusive. Theories suggest it may have contained components such as petroleum, sulfur, and quicklime, but the true recipe continues to perplex researchers. The loss of the secret of Greek fire occurred gradually as the Byzantine Empire declined. By the time Constantinople fell to the Ottoman Turks in 1453, the knowledge of how to produce this powerful weapon had vanished, leaving behind only legends and speculation about its true nature. Greek fire, a mysterious incendiary weapon, first appeared on the battlefield in the year 673. The Byzantine Empire, facing a massive Arab siege of Constantinople, unveiled this devastating new tool of war. As the Arab fleet approached the city walls, Byzantine ships suddenly unleashed streams of burning liquid that could not be extinguished with water. The flames spread rapidly across enemy vessels, sowing panic and destruction. This revolutionary weapon gave the Byzantines a crucial advantage in naval warfare. Greek fire could be projected through tubes mounted on ships, much like modern flamethrowers, or hurled in containers like grenades. Its exact composition remains a subject of debate among historians and scientists to this day, with the Byzantines guarding the secret formula zealously. The introduction of Greek fire marked a turning point in military technology. It allowed the Byzantine Empire to maintain naval supremacy in the Mediterranean for centuries, repelling numerous invasions and sieges. The psychological impact of this weapon was as significant as its physical destructiveness, striking terror into the hearts of enemies who faced an unstoppable, seemingly supernatural force. Greek fire was a formidable weapon that gave the Byzantine Empire a significant military advantage for centuries. This incendiary weapon was renowned for its ability to continue burning even when doused with water, making it particularly effective in naval warfare. The secret formula for Greek fire was so closely guarded that it remains a mystery to this day, adding to its legendary status. The effectiveness of Greek fire stemmed from several key factors. First, its ability to float on water while still burning allowed it to spread across the surface of the sea, engulfing enemy ships in flames. This made it nearly impossible for opposing forces to extinguish the fire using conventional methods. Second, the intense heat and thick smoke produced by Greek fire created panic and confusion among enemy ranks, hampering their ability to respond effectively. Furthermore, the psychological impact of Greek fire cannot be overstated. The sight of unstoppable flames and the terrifying roar of the fire as it was projected from specialized tubes mounted on Byzantine ships struck fear into the hearts of their opponents. This fear factor often led to the demoralization and retreat of enemy forces before direct combat even began. The versatility of Greek fire also contributed to its effectiveness. While primarily used in naval battles, it could also be deployed in siege warfare, poured into jars and hurled at enemy fortifications, or used to create defensive fire barriers. This adaptability made Greek fire a valuable asset in various military scenarios, cementing its place as one of the most feared weapons of the medieval world. Greek fire was a formidable weapon that gave the Byzantine Empire a significant military advantage for centuries. This incendiary weapon was renowned for its ability to continue burning even on water, making it particularly effective in naval warfare. The Byzantines zealously guarded the secret of its composition, ensuring that the exact formula remained a mystery to their enemies. The effectiveness of Greek fire lay not only in its destructive power, but also in the psychological impact it had on opposing forces. The sight of flames that could not be extinguished by conventional means struck fear into the hearts of enemies, often causing them to retreat before engaging in battle. This psychological edge, combined with its tactical advantages, made Greek fire an invaluable asset to the Byzantine military. The secrecy surrounding Greek fire was maintained through strict protocols. Knowledge of its composition and deployment was limited to a select few, often passed down within families. The Byzantine government took extreme measures to prevent the formula from falling into enemy hands, including severe punishments for those who attempted to reveal the secret. To this day, the exact composition of Greek fire remains unknown, testament to the effectiveness of the Byzantine security measures. This enduring mystery has contributed to the legendary status of Greek fire, cementing its place as one of the best-kept military secrets in history. Its legacy continues to fascinate historians and military strategists, serving as a prime example of how technological superiority and secrecy can shape the course of warfare. Greek fire remains one of history's most intriguing military secrets. This ancient incendiary weapon, used by the Byzantine Empire, was renowned for its ability to burn on water, making it a formidable naval weapon. While its exact composition has been lost to time, several theories exist about its ingredients. One prominent theory suggests that Greek fire contained petroleum or naphtha as a base, mixed with pine resin and sulfur. This combination would create a sticky, flammable substance that adhered to surfaces and was difficult to extinguish. Some historians believe quicklime might have been added, which would react with water to generate heat and ignite the mixture. Another hypothesis proposes that Greek fire included saltpeter, an ingredient later used in gunpowder. This could explain its explosive properties and ability to self-ignite. Some researchers speculate that animal fats or oils might have been incorporated to increase the fuel's viscosity and burning duration. Despite numerous attempts to recreate Greek fire, its exact formula remains elusive. The Byzantine Empire guarded this secret weapon zealously, with its composition known only to a select few. This level of secrecy has ensured that the true nature of Greek fire continues to fascinate historians and scientists alike, sparking ongoing debates and research into this ancient technological marvel. Greek fire was a formidable weapon used by the Byzantine Empire in naval warfare. This incendiary substance was deployed from ships through specially designed siphons, which could project the flaming liquid onto enemy vessels. The exact composition of Greek fire remains a mystery, but its effects were devastating. In naval battles, Byzantine ships would approach enemy vessels and unleash streams of Greek fire. The weapon was particularly effective because it continued to burn even on water, making it nearly impossible for enemies to extinguish. This characteristic allowed the Byzantines to set fire to enemy ships, sow panic among opposing crews, and gain a significant tactical advantage. The deployment of Greek fire required skilled operators and specialized equipment. The substance was stored in pressurized containers on Byzantine ships, and when released, it created a terrifying jet of flame. This spectacle not only caused physical damage, but also had a powerful psychological impact on enemy forces. Greek fire played a crucial role in several important Byzantine naval victories, including the defense of Constantinople against Arab sieges in the 7th and 8th centuries. Its use helped maintain Byzantine naval supremacy in the Mediterranean for centuries, demonstrating the significant impact of this early form of chemical warfare on medieval naval combat. Greek fire remains one of history's most intriguing mysteries. This legendary incendiary weapon, used by the Byzantine Empire, was renowned for its ability to burn even on water, striking terror into enemy forces. The exact formula for Greek fire has been lost to time due to the extreme secrecy surrounding its production and use. The Byzantine emperors recognized the strategic importance of Greek fire and went to great lengths to keep its composition a closely guarded state secret. Only a select few individuals, typically members of a single family, knew the complete formula and manufacturing process. This knowledge was passed down orally from generation to generation, with strict measures in place to prevent its spread beyond the trusted circle. The fall of the Byzantine Empire likely contributed to the loss of the Greek fire formula. As the empire declined, the chain of knowledge transmission may have been broken, and the secret recipe was not recorded in any surviving documents. Additionally, the components used in Greek fire may have been described using code names or obscure terminology, further complicating efforts to recreate the mixture. While modern scientists and historians have proposed various potential compositions for Greek fire, none have been able to replicate its legendary properties fully. The loss of this formula serves as a reminder of how easily knowledge can be lost when not properly preserved, even for inventions of great historical significance. Modern incendiary weapons have evolved significantly since the days of Greek fire, but some share similar characteristics. Napalm is perhaps the most well-known modern equivalent, consisting of a gelled petroleum substance that ignites easily and adheres to surfaces. Like Greek fire, napalm burns intensely and is difficult to extinguish with water. Thermobaric weapons, also known as fuel-air explosives, create a high-temperature fireball and devastating pressure wave. While not identical to Greek fire, they produce an intense, widespread conflagration that can be challenging to combat. These weapons disperse a fuel mixture as a fine aerosol before ignition, creating a powerful and far-reaching blast. White phosphorus munitions are another type of modern incendiary weapon. When exposed to air, white phosphorus ignites spontaneously and burns extremely hot. It can cause severe burns and is notoriously difficult to extinguish, much like the legendary Greek fire. Metal-augmented charge weapons represent a more recent development in incendiary technology. These devices use reactive metals like aluminum or magnesium to produce intense heat and light upon detonation. While the specifics differ from Greek fire, they share the ability to create persistent, high-temperature fires that are challenging to extinguish. The Lycurgus cup is a remarkable artifact from ancient Rome, dating back to the 4th century. This extraordinary drinking vessel is not only a testament to the skill of ancient craftsmen, but also an accidental triumph of nanotechnology. The cup is made of glass and features a scene depicting the death of King Lycurgus of Thrace. What makes the Lycurgus cup truly unique is its ability to change color depending on how light passes through it. When lit from the front, the cup appears green. However, when light shines through it from behind, it transforms to a brilliant red color. This effect, known as dichroism, puzzled scientists for centuries. The secret behind this color-changing phenomenon was only discovered in the 1990s with the advent of modern microscopy. Researchers found that the glass contains tiny particles of gold and silver, each measuring about 50 nanometers across. These nanoparticles interact with light in different ways depending on its direction, causing the dramatic color shift. Interestingly, the Roman artisans who created the Lycurgus cup had no knowledge of the scientific principles behind its color-changing properties. They stumbled upon this effect through trial and error, creating a masterpiece that continues to captivate both scientists and art enthusiasts to this day. The cup serves as a bridge between ancient craftsmanship and modern nanotechnology, showcasing the ingenuity of our ancestors. The Lycurgus cup, a remarkable artifact of ancient Roman glassmaking, was created in the 4th century CE. This extraordinary vessel is a testament to the advanced technological capabilities of Roman artisans during the late imperial period. Crafted with meticulous skill, the cup showcases a level of sophistication that was unparalleled in its time and remains impressive even by modern standards. What makes the Lycurgus cup truly exceptional is its unique optical properties. The glass appears green when light is reflected off its surface, but when light is transmitted through it, the cup takes on a striking red hue. This fascinating color-changing effect, known as dichroism, was achieved through the incorporation of tiny gold and silver nanoparticles within the glass matrix. The creation of the Lycurgus cup represents a pinnacle of Roman craftsmanship and scientific understanding, albeit likely achieved through empirical methods rather than a full comprehension of the underlying principles. Its existence demonstrates that ancient civilizations were capable of producing complex and sophisticated works that continue to intrigue and inspire us today. This remarkable artifact serves as a bridge between ancient ingenuity and modern nanotechnology, showcasing the timeless nature of human curiosity and innovation in manipulating materials to create objects of both beauty and scientific interest. The Lycurgus cup, a Roman artifact from the 4th century, displays remarkable optical properties that have fascinated scientists and art historians for generations. This extraordinary goblet changes color depending on how light interacts with it, a phenomenon known as dichroism. When light shines through the cup from behind, it glows a vibrant ruby red. However, when light is reflected off its surface, the cup appears a striking jade green. This color-changing effect is due to the presence of tiny gold and silver nanoparticles embedded within the glass. These particles, measuring just 50 nanometers in diameter, interact with light in complex ways. The specific size and distribution of these nanoparticles cause them to resonate with different wavelengths of light, resulting in the observed color shift. The Lycurgus cup represents one of the earliest known examples of nanotechnology, though its creators were unaware of the scientific principles behind its unique properties. Modern analysis has revealed that the ratio of gold to silver nanoparticles in the glass is crucial to achieving this dichroic effect. This ancient artifact continues to inspire researchers in the fields of optics and materials science. The cup not only showcases the advanced craftsmanship of ancient Roman glassmakers, but also serves as a bridge between ancient art and modern nanotechnology. Its enduring allure lies in the seamless blend of artistic beauty and scientific wonder, making it a testament to human ingenuity across millennia. The Lycurgus cup, a remarkable artifact from ancient Rome, exhibits an extraordinary optical phenomenon that has fascinated scientists and art enthusiasts for centuries. This 4th century glass vessel appears green when light shines upon it from the outside, but transforms to a vibrant ruby red when illuminated from within. This captivating color-changing effect is due to the presence of tiny gold and silver nanoparticles embedded within the glass. These particles, measuring mere billionths of a meter in size, interact with light in a unique way. When light strikes the cup from the outside, the nanoparticles primarily scatter green light, giving the cup its jade-like appearance. However, when light passes through the glass from the inside, the nanoparticles absorb and reflect specific wavelengths, causing the cup to glow with a rich red hue. The ancient Roman artisans who created the Lycurgus cup unknowingly pioneered a field of science that would not be fully understood for over a millennium. This phenomenon, now known as surface plasmon resonance, involves the interaction between light and the electrons in metal nanoparticles. The precise size, shape, and composition of these nanoparticles determine which wavelengths of light are absorbed or scattered, resulting in the observed color changes. The Lycurgus cup stands as a testament to the sophisticated craftsmanship of ancient civilizations and serves as an early example of nanotechnology, long before the term was coined. Its ability to change color under different lighting conditions continues to inspire modern research in fields such as optics, materials science, and sensor technology. The Lycurgus cup is a remarkable artifact from ancient Rome, dating back to the 4th century. This extraordinary vessel is made primarily of glass, but it's the unique composition of this glass that gives the cup its fascinating properties. The ancient craftsmen who created it used a mixture of gold and silver nanoparticles, though they were unaware of the concept of nanotechnology at the time. The glass contains tiny amounts of gold and silver, estimated to be about 0.005% gold and about 0.03% silver. These minute quantities were ground into incredibly fine particles and mixed into the molten glass during the manufacturing process. The result is a dichroic glass that changes color depending on how light passes through it. In addition to the precious metals, the glass also contains small amounts of sodium, lime, and lead. These ingredients were common in Roman glassmaking and helped to stabilize the glass and lower its melting point. The combination of these materials created a glass that was both durable and visually stunning. The intricate decorative scene on the cup was created using a technique called diatratum, where the glass was carefully cut and carved to create a delicate openwork design. This meticulous craftsmanship, combined with the unique properties of the dichroic glass, makes the Lycurgus cup a true masterpiece of ancient Roman technology and artistry. The Lycurgus cup, a remarkable artifact from the 4th century, showcases an astonishing feat of ancient Roman craftsmanship. This unique glass vessel changes color depending on how light passes through it, appearing green when lit from the outside and a vibrant red when illuminated from within. The secret behind this captivating effect lies in the unintentional use of nanotechnology by Roman glassmakers. They unknowingly incorporated tiny particles of gold and silver, measuring just 50 nanometers in diameter, into the glass mixture. These nanoparticles, far too small to be seen by the naked eye, interact with light in a fascinating way. When light strikes the cup from the outside, the nanoparticles primarily reflect green and yellow wavelengths, giving the cup its greenish appearance. However, when light shines through the glass from the inside, the nanoparticles absorb and scatter the blue and green wavelengths, while allowing the red light to pass through, resulting in the cup's striking red glow. This phenomenon, known as surface plasmon resonance, was achieved by Roman artisans through a process called metal reduction. They likely added small amounts of gold and silver to the molten glass, along with other elements that helped create the ideal conditions for nanoparticle formation. The precise recipe and techniques used remain a subject of ongoing research and speculation among modern scientists and historians. The Lycurgus cup, a remarkable artifact from ancient Rome, showcases a technological marvel that has puzzled scientists for centuries. This 4th century drinking vessel exhibits an extraordinary optical effect. It appears green when light shines on it from the outside, but glows a vibrant red when illuminated from within. This phenomenon, known as dichroism, results from the presence of tiny gold and silver nanoparticles embedded in the glass. The exact method used to create this effect has long been considered lost to time. Ancient glassmakers somehow managed to incorporate these nanoparticles into the glass in precise quantities and distributions, achieving a level of control over materials at the nanoscale that was not rediscovered until modern times. The technology behind the Lycurgus cup was so advanced that it took nearly 16 centuries and the development of electron microscopy for scientists to begin understanding how it was made. What makes this technology truly lost is the lack of historical records or similar artifacts from the same period. The Lycurgus cup stands as a unique example of this sophisticated technique, with no evidence of widespread use or knowledge of the process in ancient times. This suggests that the creation of the cup might have been a fortuitous accident or the closely guarded secret of a single artisan or workshop. The inability to replicate the exact process used to create the Lycurgus cup, despite our advanced modern technology, further emphasizes the loss of this ancient knowledge. While we can now create similar effects using modern nanotechnology, the original method remains a mystery, leaving us to marvel at the ingenuity of ancient craftsmen who achieved such remarkable results without the benefit of our scientific understanding. Modern scientists have been fascinated by the unique optical properties of the Lycurgus cup, an ancient Roman artifact that changes color depending on how light passes through it. This remarkable effect, known as dichroism, has inspired researchers to develop new materials and technologies that mimic and enhance these color-changing capabilities. One approach scientists have taken is to create nanoplasmonic materials. These are substances embedded with tiny metallic particles, often gold or silver, at the nanoscale level. When light interacts with these nanoparticles, it can produce a range of optical effects, including color changes similar to those seen in the Lycurgus cup. Researchers have experimented with different sizes, shapes, and arrangements of nanoparticles to fine-tune these effects. Another avenue of exploration has been the development of metamaterials. These are artificially engineered structures designed to interact with light in ways not found in nature. By carefully controlling the composition and geometry of these materials at the microscopic level, scientists can create surfaces that change color or appearance based on viewing angle or lighting conditions. These modern attempts to replicate the Lycurgus cup effect have led to potential applications in various fields. For instance, researchers are exploring their use in advanced sensing technologies, security features for documents and currency, and even in creating dynamic, color-changing surfaces for architecture and design. While the ancient artisans may not have fully understood the science behind their creation, their work continues to inspire cutting-edge research in optics and materials science today. Stonehenge is an ancient and mysterious monument located on Salisbury Plain in Wiltshire, England. This prehistoric structure consists of massive standing stones arranged in a circular pattern, with some stones weighing up to 40 tons. Built in several stages between 5,000 and 4,000 years ago, Stonehenge has captivated the imagination of people for centuries. The iconic stone circle is composed of two types of stones: the larger sarsen stones and the smaller bluestones. The sarsen stones, primarily used for the outer ring and inner horseshoe, were transported from nearby quarries. The bluestones, however, were brought from the Preseli Hills in Wales, over 150 miles away, an incredible feat of ancient engineering and determination. While the exact purpose of Stonehenge remains a subject of debate among archaeologists and historians, several theories have been proposed. Some suggest it served as an ancient observatory, aligning with celestial events like solstices and equinoxes. Others believe it was a place of healing, a burial ground for elite members of society, or a site for important religious ceremonies. Recent excavations and scientific studies continue to uncover new information about Stonehenge, shedding light on the lives of the people who built it and the techniques they used. Despite these advancements, Stonehenge remains one of the world's great archaeological mysteries, a testament to the ingenuity and ambition of our ancient ancestors. Stonehenge, the iconic prehistoric monument in Wiltshire, England, was built in several stages over a period of about 1,500 years. The earliest construction at the site began around 5,000 years ago, during the late Neolithic period, around 3,100 BCE. The first phase involved the creation of a circular ditch and bank, along with some timber structures. This initial stage was followed by the erection of the famous bluestones, which were transported from Wales, a distance of more than 250 kilometers. This incredible feat of ancient engineering occurred around 2,900 BCE. The most recognizable features of Stonehenge, the massive sarsen stones, were added during the third phase of construction around 2,500 BCE. These enormous stones, weighing up to 40 tons each, were arranged in the distinctive circle and horseshoe shape we see today. The precision with which these stones were placed and fitted together demonstrates the remarkable skill and knowledge of the Neolithic builders. Archaeological evidence suggests that modifications and refinements continued at Stonehenge until around 1,600 BCE. This long period of construction and use underscores the enduring importance of the site to the people of ancient Britain, making Stonehenge a testament to the ingenuity and dedication of our prehistoric ancestors. Stonehenge, the iconic prehistoric monument in England, was constructed using two main types of stone, sarsen and bluestone. The massive sarsen stones, which form the iconic outer circle and trilithons, are a type of sandstone found naturally in the Marlborough Downs, about 20 miles north of Stonehenge. These enormous blocks weigh up to 40 tons each and stand up to 30 feet tall. The smaller bluestones, weighing up to 4 tons each, have a more mysterious origin. Geologists have traced these stones to the Preseli Hills in Wales, nearly 150 miles away from Stonehenge. This discovery has led to fascinating debates about how these heavy stones were transported such a long distance in prehistoric times. Recent archaeological evidence suggests that the builders of Stonehenge also used wooden posts in earlier phases of construction. These wooden elements have long since decayed, but the post holes remain, offering clues about the monument's evolution over time. The construction of Stonehenge was not a single event, but occurred in several stages over a period of more than 1,000 years. The choice and transportation of these specific stones demonstrate the incredible ingenuity, determination, and engineering skills of our Neolithic ancestors. The transportation of Stonehenge's massive stones remains a subject of fascination and ongoing research. The bluestone rocks, weighing up to 4 tons each, were quarried in the Preseli Hills of Wales, nearly 150 miles away from Stonehenge's location on Salisbury Plain. These stones were likely transported using a combination of land and water routes. Archaeologists believe that the ancient builders used wooden rollers and sleds to drag the stones overland. They might have utilized a network of rivers and rafts to float the heavy loads for part of the journey. The larger sarsen stones, some weighing up to 30 tons, were sourced closer to the site, about 20 miles north of Stonehenge. These enormous blocks were probably moved using sledges and ropes, with teams of people and possibly oxen pulling them across the landscape. Recent experiments have shown that groups of people could move stones of this size using these methods, though it would have required immense effort and coordination. Some researchers suggest that the builders might have taken advantage of glacial movements during the last ice age, which could have transported some of the stones part of the way. The transportation of these massive stones represents an incredible feat of ancient engineering and human determination. It demonstrates the importance of Stonehenge to its builders, who were willing to invest enormous time and resources into creating this enigmatic monument that continues to captivate us today. The construction of Stonehenge remains a subject of fascination and ongoing research for archaeologists and historians. Recent studies have shed light on some of the techniques likely used by its Neolithic builders to erect the massive standing stones. One key method involved digging deep socket holes into the chalk bedrock. These holes were carefully shaped to accommodate the base of each standing stone. The builders then used a combination of levers, ropes, and possibly wooden rollers to maneuver the enormous stones into position. Once a stone was positioned over its designated hole, teams of workers would have pulled on ropes to gradually tilt it upright, while others used timber levers to guide and support the stone as it was lowered into place. Evidence suggests that the builders also employed a technique called the stone-moving sledge. This involved laying down a track of wooden planks and using teams of people to pull the stones along on wooden sledges. For the larger sarsen stones, which could weigh up to 40 tons, it is estimated that it would have taken at least 100 people to move a single stone. The precision of Stonehenge's construction is remarkable, considering the limited tools available at the time. The builders likely used a system of ramps and platforms to work on the upper portions of the stones, carefully shaping and fitting the lintels that sit atop the standing stones. This level of engineering skill demonstrates the ingenuity and determination of our Neolithic ancestors in creating this enduring monument. Stonehenge remains one of the most enigmatic structures from prehistoric times, captivating researchers and the public alike. While its exact purpose continues to be debated, archaeologists have uncovered compelling evidence about its significance to ancient people. The massive stone circle, erected over 4,000 years ago in what is now Wiltshire, England, likely served multiple functions. One primary role was as a celestial observatory. The alignment of the stones corresponds precisely with the movements of the sun and moon, suggesting that Stonehenge was used to track important celestial events such as solstices and equinoxes. This astronomical knowledge would have been crucial for early agricultural societies to determine planting and harvesting seasons. Stonehenge also appears to have been a place of healing and pilgrimage. Analysis of human remains found at the site indicates that many individuals traveled great distances to reach Stonehenge, possibly seeking cures for ailments. The bluestones, transported from Wales, were believed to possess healing properties, further supporting this theory. Additionally, Stonehenge served as a burial ground and a site for elaborate rituals. Archaeologists have discovered the cremated remains of hundreds of individuals interred at the site, suggesting its importance as a final resting place for the elite. The immense effort required to construct Stonehenge, involving the transportation of massive stones over long distances, underscores its significance as a gathering place for religious and social ceremonies, uniting diverse communities in a shared cultural experience. Stonehenge has long fascinated researchers with its potential astronomical alignments. While it certainly has some connections to celestial events, its accuracy as an astronomical calendar is a subject of ongoing debate among archaeologists and astronomers. The most well-established astronomical alignment at Stonehenge is its orientation towards the summer solstice sunrise. The monument is arranged so that on the longest day of the year, the sun rises directly over the heel stone when viewed from the center of the circle. This alignment suggests that the builders had a keen awareness of solar movements and likely used the monument to mark important seasonal changes. However, claims about Stonehenge's ability to predict eclipses or track complex lunar cycles are more controversial. Some researchers have proposed that the arrangement of stones could have been used to predict lunar eclipses, but these theories remain speculative and are not universally accepted by the scientific community. It is important to note that while Stonehenge demonstrates a clear interest in celestial events, calling it an accurate astronomical calendar might be an overstatement. The monument was likely used for a variety of purposes, including religious ceremonies and social gatherings, with its astronomical alignments being just one aspect of its significance to the ancient people who built and used it. Archaeologists and researchers have employed a range of cutting-edge technologies to unravel the mysteries of Stonehenge. Ground-penetrating radar has revolutionized our understanding of the site, allowing scientists to peer beneath the surface without disturbing the ancient stones. This non-invasive technique has revealed hidden structures and features, including a previously unknown ring of massive pits surrounding the monument. Laser scanning technology has been used to create incredibly detailed three-dimensional models of the stones, enabling researchers to study their shapes and surfaces with unprecedented precision. These scans have uncovered subtle details, such as tool marks and carvings, that were previously invisible to the naked eye. Sophisticated dating methods, including radiocarbon dating and optically stimulated luminescence, have helped archaeologists establish a more accurate timeline for the construction and use of Stonehenge. These techniques have shown that the site was in use for over 1,000 years, with different phases of construction and modification. Isotope analysis of human and animal remains found at the site has provided insights into the origins and movements of the people who built and visited Stonehenge. This technology has revealed that some individuals traveled from as far away as Wales and Scotland, suggesting Stonehenge was a site of pilgrimage and gathering for people across ancient Britain. The Great Pyramid of Giza stands as an enduring testament to ancient Egyptian ingenuity and architectural prowess. This colossal structure was built approximately 4,500 years ago, during the reign of Pharaoh Khufu in the 4th dynasty of Egypt's Old Kingdom period. Archaeologists and historians have determined that construction of the Great Pyramid began around 2,560 years before the Common Era. The project is believed to have taken about 20 years to complete, with the final touches added around 2,540 years before the Common Era. For millennia, the Great Pyramid held the title of the tallest human-made structure on Earth, a record it maintained for an astonishing 3,800 years. This ancient wonder has weathered the passage of time, witnessing the rise and fall of countless civilizations while remaining a source of fascination for scholars and tourists alike. The age of the Great Pyramid serves as a humbling reminder of the vast span of human history and the remarkable achievements of our ancestors. Its endurance through 45 centuries stands as a testament to the skill and vision of its builders, who created a monument that continues to captivate our imagination in the modern age. The Great Pyramid of Giza, an ancient wonder that has captivated humanity for millennia, was primarily constructed using massive limestone blocks. These enormous stones were quarried from nearby sites and transported to the construction area. The majority of the limestone came from quarries just south of the pyramid site, providing the bulk of the material for the core structure. For the outer casing of the pyramid, builders used a finer white limestone that was quarried from Tura, located across the Nile River. This high-quality limestone created a smooth, polished surface that would have made the pyramid gleam in the sunlight. Unfortunately, most of this outer casing has been lost over time. Granite, a harder and denser stone, was also utilized in specific areas of the pyramid. It was brought from quarries in Aswan, hundreds of miles to the south. Granite was used for certain internal chambers, particularly the king's chamber, and for structural elements like beams and portcullises. Mortar, made from gypsum and lime, was used to fill gaps between the massive stone blocks, helping to bind them together and create a more stable structure. This mortar, combined with the precise cutting and placement of the stones, contributed to the pyramid's remarkable durability, allowing it to withstand the test of time for over 4,000 years. The ancient Egyptians achieved remarkable precision in pyramid construction through a combination of advanced knowledge, meticulous planning, and ingenious techniques. Their understanding of mathematics and geometry played a crucial role, allowing them to create nearly perfect right angles and align the pyramid's sides with the cardinal directions. One key to their precision was the use of sophisticated surveying tools. The Egyptian plumb bob, a weight suspended on a string, helped ensure vertical alignment. They also employed a tool called a merket, similar to an astrolabe, to establish accurate north-south orientations by observing the night sky. The Egyptians' mastery of stone cutting and transportation was equally impressive. They developed techniques to cut limestone blocks with incredible accuracy, often fitting them together with gaps of less than a millimeter. To move these massive stones, they likely used a system of ramps, levers, and rollers, although the exact methods remain a subject of debate among archaeologists. Perhaps most crucial to their precision was the Egyptians' careful planning and project management. They divided the construction into stages, working from the bottom up and constantly checking their measurements. This methodical approach, combined with their advanced tools and techniques, allowed them to create structures of astonishing accuracy that continue to amaze us thousands of years later. The ancient Egyptians employed a variety of tools to cut and shape the massive limestone blocks used in constructing the Great Pyramid of Giza. Copper chisels were among the primary instruments utilized for this monumental task. These chisels, though relatively soft by modern standards, proved effective when combined with abrasive sand and constant resharpening. Bronze saws also played a crucial role in the stone-cutting process. These saws, often over 2 meters in length, were used to slice through limestone blocks with remarkable precision. The Egyptians enhanced the saw's cutting power by adding quartz sand as an abrasive agent, significantly speeding up the cutting process. For shaping and smoothing the stones, ancient builders relied on granite hammers and dolerite pounders. These harder stone tools allowed workers to precisely shape the softer limestone blocks, ensuring a tight fit between adjacent stones. Wooden rollers and sleds facilitated the movement of the massive stone blocks, while ramps aided in transporting them to higher levels of the pyramid. Interestingly, recent evidence suggests that the ancient Egyptians might have used wet sand to reduce friction when moving heavy stones. This ingenious technique would have significantly eased the arduous task of transporting multi-ton blocks across the desert landscape, showcasing the innovative thinking of these ancient builders. The construction of the Great Pyramid of Giza remains a marvel of ancient engineering. To move the massive limestone blocks, each weighing between 2.5 and 15 tons, the ancient Egyptians employed a combination of ingenious techniques and sheer manpower. One widely accepted method involved the use of ramps. As the pyramid grew taller, long, straight ramps were built alongside it. Teams of workers would drag the stone blocks up these ramps using ropes and sleds. The ramps were likely made of mud brick, limestone chips, and other materials, which could be easily dismantled once construction was complete. For the higher levels of the pyramid, some experts believe the Egyptians used a spiraling ramp that wound around the structure as it rose. This approach would have allowed for a gentler slope, making it easier to transport the heavy stones. Others suggest a system of levers and counterweights might have been used to lift the blocks into place. Recent discoveries have also pointed to the possible use of internal ramps within the pyramid itself. This theory proposes that the ancient builders created a continuous, spiraling tunnel inside the pyramid, which they used to transport blocks to the upper levels. Regardless of the exact methods used, the construction of the pyramids remains a testament to the ingenuity and organizational skills of the ancient Egyptians. The Great Pyramid of Giza, built for Pharaoh Khufu, contains a complex network of internal structures that continue to fascinate archaeologists and historians. At its core lies the King's Chamber, a grand room constructed entirely of granite blocks. This chamber houses an empty sarcophagus and features peculiar shafts that extend towards the exterior of the pyramid. Below the King's Chamber, we find the Queen's Chamber. Despite its name, it was likely never intended for a queen. This room remains a mystery, with its purpose still debated by experts. Like the King's Chamber, it also has shafts extending outward, though these were blocked before reaching the exterior. Perhaps the most intriguing feature is the Grand Gallery, a long, sloping passageway that leads to the King's Chamber. Its precise construction and corbelled design demonstrate the ancient Egyptians' remarkable engineering skills. At the base of the pyramid, we find the subterranean chamber, an unfinished room carved directly into the bedrock beneath the pyramid. Recent technological advancements have revealed previously unknown voids within the pyramid, including a large cavity above the Grand Gallery discovered in 2017. These findings suggest that the Great Pyramid may still hold secrets waiting to be uncovered, continuing to challenge our understanding of this ancient wonder. The ancient Egyptians achieved remarkable precision in aligning their pyramids with the cardinal directions, a feat that continues to impress modern engineers and archaeologists. Their primary method involved careful astronomical observations, particularly of the night sky. One key technique they employed was tracking the movement of circumpolar stars, those that never set below the horizon. By observing the rotation of these stars around the celestial pole, Egyptian surveyors could establish a highly accurate north-south line. They likely used a tool called a merket, a sighting instrument that allowed them to align 2 points with a specific star, creating a straight line on the ground. The Egyptians also utilized the sun's position to refine their alignments. They would track the shadow cast by a vertical rod, known as a gnomon, throughout the day. The shortest shadow would indicate true north, allowing them to make adjustments to their initial stellar alignments. This combination of nighttime and daytime observations enabled them to achieve an impressive level of accuracy. Recent studies have shown that the base of the Great Pyramid of Giza is aligned to true north with an error of less than 1/10 of a degree. This extraordinary precision demonstrates the ancient Egyptians' advanced understanding of astronomy and their meticulous approach to construction, setting a standard that would be challenging to match even with modern technology. The mysterious shafts within the Great Pyramid of Giza have puzzled archaeologists and researchers for centuries, leading to several intriguing theories about their purpose. One prominent idea suggests these shafts were designed as pathways for the pharaoh's soul to ascend to the heavens. This theory aligns with ancient Egyptian beliefs about the afterlife and the importance of facilitating the ruler's journey to join the gods. Another hypothesis proposes that the shafts served a practical function during the pyramid's construction. Some experts believe they might have been used to transport materials or as a means of ventilation for workers inside the massive structure. This theory emphasizes the engineering prowess of the ancient Egyptians and their ability to solve complex logistical challenges. A more recent and controversial theory suggests the shafts could have been used for astronomical observations. Proponents of this idea argue that the angles of the shafts align with specific celestial bodies that held significance in ancient Egyptian religion and timekeeping. This concept links the pyramid's design to the Egyptians' advanced understanding of astronomy and their desire to connect earthly structures with cosmic phenomena. Some researchers have also proposed that the shafts might have played a role in rituals or ceremonies conducted within the pyramid. They speculate that these passages could have been used to channel sunlight or starlight into specific chambers at particular times, possibly for religious or symbolic purposes. While the true purpose of these enigmatic shafts remains a subject of debate, each theory offers a fascinating glimpse into the complexity and ingenuity of ancient Egyptian civilization. Göbekli Tepe is an extraordinary archaeological site located in southeastern Turkey. This ancient complex of circular structures dates back to the 10th millennium before the Common Era, making it older than Stonehenge by about 6,000 years. The site consists of several rings of massive stone pillars, many of which are adorned with intricate carvings of animals and abstract symbols. What makes Göbekli Tepe truly remarkable is that it was built during a time when humans were thought to be simple hunter-gatherers, not yet capable of complex architectural feats. The construction of such a large and sophisticated site challenges our understanding of early human societies and their capabilities. It suggests that organized religion and complex social structures may have emerged earlier than previously believed. Archaeologists have only excavated a small portion of Göbekli Tepe, and much of the site remains buried beneath the earth. The purpose of this ancient complex is still debated, with theories ranging from a religious sanctuary to an astronomical observatory. Whatever its original function, Göbekli Tepe has revolutionized our view of prehistoric human civilization and continues to spark intense scientific interest and debate. The discovery of Göbekli Tepe has forced historians and archaeologists to reconsider the timeline of human cultural development. It stands as a testament to the ingenuity and organizational skills of our ancient ancestors, hinting at a more complex prehistoric world than we ever imagined. Göbekli Tepe, a remarkable archaeological site in southeastern Turkey, was constructed approximately 12,000 years ago. This ancient wonder dates back to the 10th millennium before the Common Era, placing its origins in the early Neolithic period. The construction of Göbekli Tepe predates many other well-known ancient structures by thousands of years. It is older than the Egyptian pyramids, Stonehenge, and even the development of agriculture as we know it. This fact has led archaeologists and historians to reconsider their understanding of early human civilization and social organization. Excavations at the site began in the 1990s, revealing a complex of circular structures supported by massive stone pillars. These pillars, some weighing up to 20 tons, were intricately carved with animal figures and abstract symbols. The sophistication of the site suggests that the hunter-gatherer societies of the time were capable of far more complex social and religious organization than previously thought. The purpose of Göbekli Tepe remains a subject of debate among experts. Some believe it served as a religious sanctuary, while others propose it might have been a center for social gatherings or astronomical observations. Regardless of its exact function, the construction of Göbekli Tepe represents a pivotal moment in human history, showcasing the capabilities of our ancestors at the dawn of settled civilization. Göbekli Tepe, an archaeological site in southeastern Turkey, has dramatically altered our perception of early human societies. Dating back approximately 12,000 years, this ancient complex predates the invention of pottery, metallurgy, writing, and even agriculture. Its existence challenges the long-held belief that complex societies only emerged after humans transitioned to farming and settled lifestyles. The monumental structures at Göbekli Tepe, with their intricate carvings and massive stone pillars, suggest a level of organization and craftsmanship previously thought impossible for hunter-gatherer societies. These structures, some standing up to 20 feet tall and weighing up to 20 tons, required significant planning, labor, and resources to construct. This implies that hunter-gatherers were capable of far more sophisticated social organization than previously believed. Furthermore, Göbekli Tepe suggests that religion or shared spiritual beliefs may have played a crucial role in the development of complex societies, possibly even predating agriculture. The site appears to have been a ceremonial center, indicating that spiritual or ideological motivations might have driven early humans to cooperate on a large scale before the advent of farming. The implications of Göbekli Tepe extend beyond archaeology, influencing our understanding of human cognitive development and social evolution. It forces us to reconsider the timeline and drivers of human progress, suggesting that our ancestors were capable of remarkable achievements much earlier than we once thought. This discovery serves as a reminder that our understanding of ancient history is continually evolving, and that there may be many more surprises waiting to be unearthed. Göbekli Tepe stands as a remarkable archaeological site that challenges our understanding of prehistoric human capabilities. Located in southeastern Turkey, this ancient complex dates back to around 10,000 years before the present, predating the invention of pottery, metallurgy, writing, and even the wheel. The most striking feature of Göbekli Tepe is its series of circular enclosures, each containing massive T-shaped limestone pillars arranged in a ring. These pillars, some standing up to 20 feet tall and weighing as much as 20 tons, were skillfully carved and transported from nearby quarries. The precision and scale of this construction are astounding, considering the limited tools available to its Neolithic builders. Many of the pillars at Göbekli Tepe are adorned with intricate relief carvings depicting various animals, including foxes, bulls, snakes, and birds. These artistic elements suggest a complex symbolic system and provide insights into the beliefs and culture of the people who created them. The quality of these carvings is remarkably sophisticated for their time, showcasing a level of artistry previously thought impossible for hunter-gatherer societies. Perhaps most intriguing is the site's purpose and layout. Unlike later Neolithic settlements, Göbekli Tepe shows no evidence of permanent habitation. This has led researchers to propose that it may have been a ceremonial center or gathering place for widely dispersed groups. The architectural layout, with its concentric circles and carefully positioned pillars, hints at a deep understanding of geometry and possibly astronomy, challenging our perceptions of early human knowledge and social organization. The massive stone pillars at Göbekli Tepe present a fascinating enigma for archaeologists and historians. These impressive structures, some weighing up to 20 tons, were created and erected by Neolithic people around 12,000 years ago, predating the invention of metal tools or even pottery. Evidence suggests that the ancient builders used flint tools to carve the limestone pillars. They likely employed a technique of repeatedly striking the stone with smaller, harder rocks to gradually shape it. This process would have been incredibly time-consuming and labor-intensive, requiring great skill and patience. To erect these colossal pillars, the builders likely used a combination of brute force and ingenious techniques. They may have employed wooden rollers and sleds to transport the pillars from nearby quarries. Once at the site, they probably dug deep sockets in the ground and used ropes, levers, and counterweights to slowly raise the pillars into position. This process would have required extensive planning and coordination among large groups of people. The precision and complexity of Göbekli Tepe challenge our understanding of early human capabilities. The site demonstrates that our ancestors were capable of sophisticated engineering and social organization long before the development of agriculture or settled societies, prompting us to reconsider the timeline of human cultural evolution. Göbekli Tepe, an ancient site in southeastern Turkey, continues to puzzle archaeologists and historians. Dating back to around 12,000 years ago, this remarkable complex of circular structures predates pottery, metallurgy, and even agriculture. Its purpose remains a subject of intense debate and speculation. Many experts believe Göbekli Tepe served as a ritual center or sanctuary. The site's massive T-shaped pillars, some weighing up to 20 tons, are adorned with intricate carvings of animals and abstract symbols. These elaborate decorations suggest the site held great symbolic and spiritual significance for its builders. Some researchers propose that Göbekli Tepe functioned as a gathering place for different hunter-gatherer groups. It may have facilitated social interactions, knowledge exchange, and perhaps even early forms of trade. This theory aligns with the site's location atop a hill, offering expansive views of the surrounding landscape. Interestingly, Göbekli Tepe's construction predates the advent of settled agricultural communities. This challenges our understanding of societal development, suggesting that complex social and religious structures may have preceded, and perhaps even driven, the transition to farming. The site's purpose, whatever it may have been, was clearly important enough to motivate early humans to undertake such a monumental building project. Archaeological excavations at Göbekli Tepe have revealed compelling evidence that this ancient site was deliberately buried by its creators. The careful and systematic way in which the structures were filled in suggests a planned and intentional process rather than natural accumulation over time. Researchers have found that the spaces between the stone pillars and walls were packed with debris consisting of limestone fragments, flint tools, and animal bones. This fill material appears to have been brought from elsewhere, indicating a deliberate effort to cover the structures. The uniformity and consistency of this fill across the site further support the idea of an organized burial process. Moreover, the excellent state of preservation of the stone carvings and structures suggests they were protected from weathering and erosion soon after their creation. Had the site been abandoned and left exposed, we would expect to see more significant degradation of these delicate features over thousands of years. The intentional burial of Göbekli Tepe raises intriguing questions about the beliefs and practices of its builders. This act might have been part of a ritual closure of the site, marking the end of its use, or perhaps preserving it for future generations. Understanding the motives behind this burial continues to be a focus of ongoing research and speculation among archaeologists studying this remarkable Neolithic site. The discovery of Göbekli Tepe has revolutionized our understanding of early human civilization and the development of agriculture. This ancient site, located in southeastern Turkey, dates back to around 10,000 years ago, predating the previously accepted timeline for the emergence of complex societies. Göbekli Tepe consists of massive stone pillars arranged in circular formations, adorned with intricate carvings of animals and abstract symbols. What makes this site truly remarkable is that it was built by hunter-gatherers, not by settled agricultural communities as previously believed. This finding challenges the long-held notion that agriculture was a prerequisite for the development of complex societies and monumental architecture. The existence of Göbekli Tepe suggests that the impetus for settling down and developing agriculture may have been driven by the need to support and maintain these early religious or ceremonial centers. This flips the traditional narrative on its head, indicating that complex social organization and shared beliefs may have preceded and potentially driven the transition to farming and settled life. Furthermore, the sophisticated nature of the structures at Göbekli Tepe implies that hunter-gatherer societies were capable of far more complex social organization than previously thought. This has led researchers to reevaluate the cognitive and technological capabilities of our early ancestors, painting a picture of a more advanced and interconnected prehistoric world. The Nazca lines are enormous geoglyphs etched into the desert floor of southern Peru. These ancient designs, some stretching over 900 feet long, depict various shapes, including animals, plants, and geometric patterns. Created by the Nazca culture between 500 BCE and 500 CE, these remarkable figures have puzzled researchers for decades. What makes the Nazca lines truly extraordinary is their scale and precision. These massive drawings are best viewed from the air, leading to speculation about how the Nazca people created such intricate designs without the ability to fly. The dry, windless climate of the Peruvian desert has preserved these fragile lines for over 2,000 years. Theories about the purpose of the Nazca Lines range from astronomical calendars to religious rituals. Some researchers suggest they were created as offerings to the gods, while others propose they served as markers for underground water sources. Despite extensive study, the true meaning and function of these enigmatic geoglyphs remain a subject of debate among archaeologists and historians. The Nazca Lines continue to captivate our imagination, serving as a testament to the ingenuity and artistic skill of ancient civilizations. Their enduring mystery invites us to ponder the capabilities and motivations of cultures long past, reminding us that there is still much to discover about our planet's rich history. The Nazca Lines, etched into the arid coastal plains of southern Peru, were created between 500 BCE and 500 CE. This remarkable feat of ancient engineering spans a period of roughly 1,000 years, coinciding with the flourishing of the Nazca culture in the region. These enormous geoglyphs, only fully visible from the air, were painstakingly crafted by removing the reddish pebbles that cover the desert surface to reveal the lighter-colored ground beneath. The extremely dry, windless climate of the Nazca Desert has preserved these delicate designs for over 1.5 millennia. Recent archaeological evidence suggests that the creation of the lines evolved over time. The earliest designs were likely simple lines and geometric shapes, while the more complex figures of animals and plants came later. This indicates a development in technique and perhaps purpose over the centuries of Nazca cultural development. The enduring nature of the Nazca Lines poses intriguing questions about their creators' intentions and the significance of these designs in ancient Nazca society. Their precise purpose remains a subject of ongoing debate among archaeologists and historians, adding to the mystique of these ancient wonders. The Nazca Lines, etched into the arid Peruvian desert, were created using surprisingly simple yet effective techniques. The ancient Nazca people removed the top layer of reddish pebbles and rocks, exposing the lighter-colored clay soil underneath. This contrast between the dark surface and the light subsurface allowed the designs to be visible from a distance. To create these massive geoglyphs, the Nazca first made smaller-scale models of their intended designs. They then used wooden stakes connected by rope to plot out the full-sized figures on the desert floor. This method, similar to modern surveying techniques, allowed them to maintain proper proportions and straight lines over vast distances. The actual removal of the top layer was done using simple tools like sticks and stones. The dry, stable climate of the Nazca region has helped preserve these delicate lines for centuries, with minimal erosion or disturbance. Some of the largest figures span several hundred meters, requiring careful planning and execution. Interestingly, the Nazca did not need to view their creations from the air to make them. By using hills and other high points in the landscape, they could see the progress of their work and ensure accuracy. This ingenious combination of planning, simple tools, and environmental factors resulted in the creation of one of the most enigmatic and impressive ancient artworks known to us today. The Nazca Lines have endured for centuries due to a combination of environmental factors and their unique construction. Located in the Nazca Desert of southern Peru, these ancient geoglyphs benefit from the region's extremely dry and stable climate. With minimal rainfall and little wind erosion, the delicate lines carved into the desert floor have remained largely undisturbed. The composition of the desert surface itself plays a crucial role in the preservation of the Nazca Lines. The ground consists of a layer of light-colored sand and pebbles, covering darker, reddish clay soil underneath. By removing the top layer, the ancient Nazca people expose the contrasting clay beneath, creating visible lines and shapes. This method of creation contributes to the longevity of the designs, as the exposed clay is more resistant to erosion than loose sand. Furthermore, the isolated nature of the Nazca Desert has protected the lines from human interference for much of their history. The area saw little development or foot traffic until their rediscovery in the 20th century. Since then, efforts have been made to preserve and protect these remarkable archaeological features, including limiting access to the site and designating it as a UNESCO World Heritage Site. The endurance of the Nazca Lines serves as a testament to the ingenuity of their creators and the unique conditions of their location. Their preservation allows us to continue studying and marveling at these ancient wonders, offering insights into the cultures that once thrived in this seemingly inhospitable desert environment. The Nazca Lines, etched into the desert floor of southern Peru, have puzzled researchers for decades. Several theories attempt to explain their purpose, each offering a unique perspective on these ancient geoglyphs. One prominent theory suggests the line served as an astronomical calendar. Proponents argue that the shapes align with celestial bodies, potentially helping the Nazca people track seasons and plan agricultural activities. This idea connects the lines to practical, everyday needs of the ancient civilization. Another intriguing hypothesis proposes that the lines were created for religious or ceremonial purposes. Some researchers believe the massive drawings were meant to be seen by the gods from above, serving as a form of communication or worship. This theory aligns with the spiritual practices observed in many ancient cultures. A more recent and controversial idea suggests extraterrestrial involvement. While lacking scientific support, this theory speculates that the lines were landing strips for alien spacecraft or messages intended for beings in the sky. Though widely dismissed by mainstream archaeologists, it continues to capture public imagination and fuel debate about the true purpose of these enigmatic designs. The Nazca people of ancient Peru created their enormous and precise geoglyphs through a combination of careful planning, mathematical knowledge, and ingenious techniques. These massive designs, some stretching over 900 feet across, were etched into the desert floor with remarkable accuracy, despite the lack of aerial perspective. Archaeologists believe the Nazca used a system of scaled-down drawings and simple surveying tools to achieve their impressive results. They likely began with small models of their intended designs, then used a grid system to enlarge these patterns onto the desert surface. Wooden stakes and rope could have been employed to mark out straight lines and create smooth curves over vast distances. The dry, stable climate of the Nazca region played a crucial role in preserving these artworks. The desert floor consists of a layer of red pebbles covering lighter-colored earth beneath. By removing the top layer, the Nazca exposed the contrasting ground underneath, creating visible lines that have endured for centuries. The precision of the Nazca lines demonstrates the advanced mathematical and astronomical knowledge of this ancient civilization. Some designs align with celestial events, suggesting the Nazca possessed a sophisticated understanding of geometry and its application to large-scale projects. Their achievement stands as a testament to human ingenuity and the ability to create monumental art without modern technology or aerial viewpoints. Satellite imagery has revolutionized our ability to study and map the Nazca lines in Peru. High-resolution photographs taken from space allow researchers to view the entire complex of geoglyphs from above, providing a comprehensive perspective that was previously impossible. This technology has enabled the discovery of new lines and figures that were not visible from ground level or even from aircraft. Drones equipped with advanced cameras have become invaluable tools for archaeologists studying the Nazca lines. These unmanned aerial vehicles can capture detailed images and three-dimensional data, allowing researchers to create precise maps and digital models of the geoglyphs. Drones also help in monitoring the site for damage and changes over time, aiding in conservation efforts. LiDAR, which stands for light detection, and ranging, has been employed to create highly accurate topographical maps of the Nazca region. This technology uses laser pulses to measure distances and create three-dimensional representations of the landscape. LiDAR can penetrate vegetation and reveal subtle changes in ground elevation, helping researchers identify previously unknown geoglyphs and understand how the lines relate to the natural terrain. Multispectral and hyperspectral imaging techniques have also been applied to study the Nazca lines. These technologies capture data across multiple wavelengths of light, including those invisible to the human eye. By analyzing these different spectral bands, scientists can gain insights into the composition of the soil and rocks used to create the geoglyphs, as well as detect faint or eroded lines that are no longer visible to the naked eye. The Nazca lines in Peru present a remarkable challenge to our understanding of ancient surveying and engineering capabilities. These enormous geoglyphs, etched into the desert floor, span an area of nearly 450 square kilometers and depict various animals, plants, and geometric shapes. Their sheer scale and precision have left researchers astounded for decades. What makes the Nazca lines particularly intriguing is the level of mathematical and astronomical knowledge required to create them. The ancient Nazca people, who lived between 500 BCE and 500 CE, managed to create perfectly straight lines over distances of several kilometers without the benefit of modern surveying equipment. This feat suggests a sophisticated understanding of geometry and the ability to maintain consistency over vast areas. Furthermore, many of the designs are only fully visible from high altitudes, indicating that the Nazca had some method of planning and visualizing their work from an aerial perspective. This challenges our assumptions about the limitations of ancient peoples' ability to conceptualize and execute large-scale projects without modern technology. The precision of the Nazca lines also raises questions about the tools and techniques used in their creation. The lines maintain their shapes and alignments despite centuries of exposure to wind and weather, suggesting a deep understanding of the local environment and materials. This level of engineering prowess forces us to reconsider the technological capabilities of ancient civilizations and the complexity of their scientific knowledge. The Antikythera Mechanism, an ancient Greek astronomical calculator, was primarily constructed using bronze. This remarkable device, dating back to around 150 to 100 BCE, showcased the advanced metallurgical and engineering skills of its creators. The main structural elements and gears of the mechanism were crafted from high-quality bronze, chosen for its durability and resistance to corrosion. This choice of material allowed the device to survive for over 2,000 years underwater before its discovery in 1901 off the coast of the Greek island of Antikythera. Recent studies have revealed that the mechanism also incorporated other materials. The front and back faces likely featured wooden frames, which unfortunately did not survive the long submersion in seawater. Additionally, researchers believe that the device included a number of bronze dials and pointers, as well as Greek inscriptions etched into bronze plates. Interestingly, there is evidence suggesting the presence of tin in some components, possibly used to create a harder alloy or as a protective coating. The craftsmanship involved in creating this complex machine, with its intricate system of gears and wheels, demonstrates the sophisticated understanding of materials and engineering principles possessed by ancient Greek astronomers and mechanics. The Antikythera Mechanism, an ancient Greek astronomical calculator, contains a complex system of gears that has fascinated researchers for decades. This remarkable device houses at least 30 gears, though some estimates suggest there could be as many as 72 gears in total. The exact number remains a subject of ongoing study and debate among scholars. These bronze gears, each precisely cut and carefully arranged, work together to perform intricate calculations. They track celestial movements, predict eclipses, and display various cycles of time. The sophistication of this gear system was unparalleled for its time, showcasing a level of technological advancement that would not be seen again for centuries. The complexity of the Antikythera Mechanism's gear system is made even more impressive by its age. Created around 150 to 100 years before the Common Era, it predates similar mechanical devices by over a millennium. This ancient computer demonstrates that the Greeks possessed far more advanced scientific and engineering knowledge than previously thought. The Antikythera Mechanism, an ancient Greek analog computer, was a remarkable device capable of predicting various astronomical cycles with astonishing accuracy. This intricate bronze mechanism could forecast the positions of the sun, moon, and planets, as well as lunar and solar eclipses. One of its primary functions was to track the Metonic cycle, a period of 19 years in which the phases of the moon recur on the same day of the year. This cycle was crucial for ancient timekeeping and calendar systems. The device could also predict the Calippic cycle, a refinement of the Metonic cycle that spans 76 years. Furthermore, the Antikythera Mechanism could calculate the Saros cycle, a period of approximately 18 years, 11 days, 8 hours between successive eclipses with similar characteristics and geometry. This allowed for accurate predictions of both solar and lunar eclipses. The mechanism also tracked the Exoligmos cycle, a triple Saros period of 54 years and 34 days, which improved eclipse predictions even further. Remarkably, this ancient computer could even model the irregular orbit of the moon, taking into account its elliptical path and varying speed as it circles the Earth. This level of sophistication in astronomical prediction would not be seen again for over a millennium, making the Antikythera Mechanism a true marvel of ancient Greek engineering and astronomical knowledge. The Antikythera Mechanism stands as a remarkable testament to the ingenuity and mathematical prowess of ancient Greek civilization. This intricate device, often described as the world's first analog computer, fundamentally reshapes our perception of technological capabilities in antiquity. Discovered in 1901 off the coast of the Greek island Antikythera, this complex mechanical calculator demonstrates a level of sophistication previously thought unattainable in the ancient world. The mechanism's ability to predict astronomical positions and eclipses for calendar and astrological purposes reveals a deep understanding of celestial mechanics and advanced mathematical concepts. What truly astonishes modern scholars is the mechanism's use of differential gearing, a technology believed to have been invented much later. This suggests that ancient Greek mathematicians and engineers possessed knowledge far beyond what historical records indicate. The device's intricate system of gears, able to model the irregular orbits of celestial bodies, points to a grasp of epicyclic theories and complex mathematical models. The Antikythera Mechanism challenges us to reevaluate the timeline of technological progress and the depth of ancient Greek mathematical understanding. It raises intriguing questions about lost knowledge and the potential for other advanced ancient technologies yet to be discovered, prompting us to reconsider the capabilities of our ancestors and the evolution of scientific thought. The Antikythera Mechanism, an ancient Greek analog computer, has revealed fascinating inscriptions that offer insights into its purpose and complexity. Researchers have discovered over 2,000 characters of text on this remarkable device, shedding light on its functions and the astronomical knowledge of its creators. Among the most significant inscriptions are those related to astronomical cycles and calendars. The mechanism features the names of months from the Corinthian calendar, as well as references to the Metonic cycle, a 19-year period after which the phases of the moon repeat on the same days of the year. Other inscriptions mention the Saros cycle, used to predict solar and lunar eclipses, and the Calippic cycle, an improvement on the Metonic cycle. The device also bears inscriptions related to the movements of celestial bodies. Text referring to the 5 planets known to the ancient Greeks has been identified, along with descriptions of their retrograde motions. Additionally, inscriptions detailing the risings and settings of specific stars have been found, indicating the mechanism's use in tracking these celestial events. Perhaps most intriguingly, some inscriptions suggest the Antikythera Mechanism may have had additional functions beyond astronomical calculations. References to the timing of the ancient Olympic Games and other Panhellenic contests have been discovered, hinting at the device's potential use as a complex calendar for both celestial and terrestrial events. Modern imaging technology has revolutionized our understanding of the Antikythera Mechanism, an ancient Greek device often called the world's first analog computer. Advanced techniques like computed tomography and surface imaging have allowed researchers to peer inside this complex artifact without damaging it, revealing intricate gears and inscriptions previously hidden from view. These cutting-edge methods have uncovered a wealth of new information about the mechanism's structure and function. We now know it contained at least 30 gears, far more than initially thought, arranged in a sophisticated system that could predict celestial events and track complex astronomical cycles. The imaging has also revealed previously unseen inscriptions, shedding light on the device's purpose and the depth of astronomical knowledge in ancient Greece. Perhaps most remarkably, three-dimensional X-ray imaging has allowed researchers to virtually reconstruct the mechanism, providing insights into its operation that were impossible with earlier techniques. This has led to a deeper appreciation of the mathematical and engineering skills of its creators, showcasing a level of technological sophistication that wouldn't be seen again for over 1,000 years. The Antikythera Mechanism stands as a testament to the ingenuity of ancient Greek scientists and engineers. Thanks to modern imaging technology, we continue to uncover its secrets, bridging the gap between ancient wisdom and contemporary understanding. The Antikythera Mechanism, an ancient Greek astronomical calculator, has fascinated scholars since its discovery in 1901. Several theories exist about its origin and creator, though no definitive answer has been found. One prominent theory suggests that the device was crafted in Rhodes, a center of astronomical learning in the ancient world. This idea is supported by the mechanism's similarity to devices described by the renowned astronomer Geminus, who lived on Rhodes in the 1st century before the Common Era. Another theory proposes that the mechanism was created by the school of the famous astronomer and mathematician Posidonius, also based in Rhodes. Posidonius was known for his work on celestial mechanics and could have had the knowledge required to design such a complex device. Some researchers have even suggested that Archimedes of Syracuse might have been involved in its creation, given the sophistication of the gears and the similarity to devices he was known to have built. A more recent theory points to the possibility that the mechanism was created in Corinth or one of its colonies. This idea is based on the Corinthian calendar month names found inscribed on the device. However, it is important to note that these names were used in various locations around the Mediterranean, not just in Corinth itself. While the exact creator remains unknown, most experts agree that the Antikythera Mechanism was likely designed and built by a team of skilled craftsmen and astronomers, rather than a single individual. The complexity and precision of the device suggest a collaborative effort, combining expertise in astronomy, mathematics, and metalworking. As research continues, new theories may emerge, shedding more light on this remarkable ancient computer. The Antikythera Mechanism stands as a remarkable testament to the ingenuity of ancient Greek technology, far surpassing the complexity of any other known device from its time. Discovered in 1901 among the wreckage of an ancient shipwreck, this intricate mechanical calculator has astounded historians and scientists alike with its sophistication. Dating back to around 100 to 200 before the Common Era, the Antikythera Mechanism was capable of tracking astronomical phenomena with astonishing accuracy. It could predict solar eclipses, calculate the positions of celestial bodies, and even account for the irregular orbit of the Moon. This level of astronomical knowledge and mechanical precision was not seen again in Europe for over a millennium. What sets the Antikythera Mechanism apart is its use of a differential gear, a component previously believed to have been invented in the 16th century. This revelation has forced scholars to reconsider the technological capabilities of ancient civilizations. The device also featured a complex system of bronze gears and dials, all housed in a wooden case roughly the size of a shoebox. The uniqueness of the Antikythera Mechanism lies not only in its complexity, but also in its apparent isolation in the historical record. No other devices of comparable sophistication have been found from the same era, leading to questions about the extent of lost ancient knowledge. Its existence suggests that the ancient Greeks possessed a level of technological and astronomical understanding far beyond what was previously thought possible for that time period. The Shroud of Turin is a famous religious artifact that has captivated both believers and skeptics for centuries. It is a long linen cloth, measuring approximately 14 feet by 3.5 feet, bearing the faint image of a man who appears to have suffered physical trauma consistent with crucifixion. Many people believe this image to be an imprint of Jesus Christ after his death. Housed in the Cathedral of Turin in Italy, the shroud has been the subject of intense scientific study and heated debate. Researchers have employed various techniques to examine the cloth, including carbon dating, spectral analysis, and microscopic investigation. These studies have yielded conflicting results, with some supporting the shroud's authenticity and others suggesting it may be a medieval creation. One of the most intriguing aspects of the Shroud of Turin is the nature of the image itself. The markings on the cloth are not composed of any known pigments or dyes, and the image has three-dimensional qualities when viewed under certain lighting conditions. This has led to numerous theories about how the image might have been formed, ranging from divine intervention to complex chemical reactions. Despite decades of research, the true origin and nature of the Shroud of Turin remain a mystery. It continues to be an object of veneration for many Christians and a source of fascination for scientists and historians alike, serving as a unique intersection of faith, science, and historical inquiry. The Shroud of Turin bears the faint image of a man who appears to have suffered physical trauma consistent with crucifixion. This mysterious cloth shows the front and back impressions of a human figure, with visible wounds on the wrists, feet, and side. The image depicts a bearded man with long hair, his arms crossed over his body. Notably, the shroud displays several features that have intrigued researchers and the public alike. The figure's face shows signs of swelling and wounds, while the body bears marks that resemble scourge wounds. The image also includes what appear to be blood stains, particularly around the head area, suggesting a crown of thorns. The nature of the image itself is unusual, appearing as a photographic negative when photographed. This characteristic was not discovered until 1896, when Italian photographer Secondo Pia took the first photographs of the shroud. The image's unique properties have fueled debate about its origins and authenticity for centuries. While some believe the shroud to be the actual burial cloth of Jesus Christ, its true nature and origin remain subjects of intense scientific and theological debate. Regardless of its authenticity, the Shroud of Turin continues to captivate people worldwide with its haunting and detailed portrayal of human suffering. The Shroud of Turin first entered historical records in the mid-14th century. Its earliest known public display occurred in France around 1356, when it was exhibited in a church in Lirey, a small town in the Champagne region. This display was organized by a French nobleman named Geoffroy de Charny, who claimed to possess the burial cloth of Jesus Christ. Prior to this date, the history of the shroud becomes less certain and more speculative. Some researchers have attempted to trace its journey from Jerusalem through various locations in the Middle East and Europe, but these accounts lack solid historical evidence. The first detailed description of the shroud came from Bishop Pierre d'Arcis in 1389. In a memorandum to Pope Clement VII, d'Arcis expressed his skepticism about the cloth's authenticity, claiming it was a clever painting and not the true burial shroud of Jesus. This documentation in the late 14th century marks the beginning of the shroud's verifiable history, though debates about its origin, age, and authenticity continue to this day, making it a subject of ongoing scientific and historical investigation. The Shroud of Turin has been a subject of intense debate and scientific scrutiny for decades. This ancient linen cloth bears the faint image of a man who appears to have suffered injuries consistent with crucifixion, leading some to believe it is the burial shroud of Jesus Christ. However, its authenticity remains highly contested. One of the main controversies stems from carbon dating tests conducted in 1988. These tests suggested that the shroud originated between 1260 and 1390 Common Era, much later than the time of Jesus. Critics argue that these results definitively prove the shroud is a medieval forgery. However, proponents of the shroud's authenticity claim that the tested samples were contaminated or taken from a repaired section of the cloth, potentially skewing the results. Another point of contention is the nature of the image itself. Scientists have been unable to conclusively explain how the image was formed. Some argue that it is a product of artistic techniques available in the Middle Ages, while others claim that no known method could produce such a detailed and three-dimensional image on fabric. Theories ranging from radiation bursts to natural chemical reactions have been proposed, but none have gained universal acceptance. The presence of pollen and dust particles on the shroud has also fueled debate. Some researchers claim to have identified pollen species native to the Jerusalem area, supporting the shroud's Middle Eastern origin. However, critics argue that these findings are inconclusive and that the pollen could have been introduced during the shroud's long history of handling and display. As research continues, the Shroud of Turin remains a fascinating enigma, blending questions of faith, history, and science. Modern scientific investigations of the Shroud of Turin have employed a range of advanced techniques to analyze its mysterious image. Researchers have used spectral imaging, carbon dating, and microscopic analysis to examine the cloth and its enigmatic markings. One prominent theory suggests that the image might be the result of a chemical reaction between linen fibers and bodily fluids. Some scientists propose that a burst of radiation or energy could have caused this reaction, creating the detailed imprint of a human form. This hypothesis attempts to explain the three-dimensional quality of the image, which has puzzled researchers for decades. Other studies have focused on the possibility of artistic creation, examining whether medieval techniques could have produced such a detailed and unique image. However, the lack of brush strokes or pigments typical of paintings from that era has challenged this explanation. Despite numerous studies, the exact mechanism behind the shroud's image formation remains a subject of debate among scientists, historians, and religious scholars. The complexity of the image and the limitations of studying an artifact of its age continue to make the Shroud of Turin a compelling subject for scientific inquiry and speculation. The Shroud of Turin has been subjected to numerous scientific analyses over the years, employing a variety of dating techniques. One of the most significant methods used was radiocarbon dating, conducted in 1988. This process involved taking small samples from the shroud and measuring the amount of carbon-14 present. The results suggested the shroud originated between 1260 and 1390 AD, much later than the time of Jesus. However, critics have questioned these findings, arguing that the tested samples may not have been representative of the entire shroud. This led to the exploration of other dating methods. Multispectral imaging has been used to analyze the cloth's weave and composition, providing insights into its age based on historical textile manufacturing techniques. Pollen analysis has also been employed, examining microscopic pollen grains trapped in the fabric to identify plant species and their geographical origins. This method aims to trace the shroud's history through its exposure to different environments. Additionally, researchers have used Raman spectroscopy and X-ray fluorescence to study the chemical composition of the fibers and image, seeking clues about the shroud's age and origin. Despite these varied approaches, the exact age and origin of the Shroud of Turin remain subjects of debate. Each technique has its strengths and limitations, and researchers continue to develop new methods to unravel the mystery surrounding this enigmatic artifact. The creation of the image on the Shroud of Turin remains a subject of intense debate and speculation. While some believe it to be a miraculous imprint, others propose that it could have been created using techniques available in medieval times. One theory suggests that the image might have been produced through a primitive form of photography. This process, known as a camera obscura, involves projecting an image through a small hole onto a surface in a darkened room. By treating a linen cloth with light-sensitive chemicals and exposing it to sunlight filtered through such a device, it might have been possible to create a rudimentary photographic negative. Another possibility is that the image was created using a rubbing technique. A sculptured figure could have been coated with a mixture of pigments and oils, then wrapped in the linen cloth. Careful rubbing and pressing could transfer the image onto the fabric, creating the distinctive features seen on the shroud. Some researchers have proposed that a combination of techniques might have been employed. For instance, a base image could have been created using pigments or scorching, with additional details added through careful application of acidic substances or other compounds that would interact with the linen fibers over time. This multi-step process could explain some of the unique characteristics of the shroud image that have puzzled scientists for decades. The study of the Shroud of Turin has significantly influenced both forensic science and imaging technology. Researchers have employed cutting-edge techniques to analyze this controversial artifact, leading to advancements in various scientific fields. In forensic science, the shroud has prompted the development of more sophisticated methods for analyzing trace evidence and blood patterns. Scientists have refined techniques for examining ancient textiles and biological materials, which have applications beyond the study of the shroud itself. These improved methods now assist in solving modern criminal cases and analyzing other historical artifacts. Imaging technology has seen remarkable progress due to shroud research. Scientists have created new ways to capture and enhance faint images, developing multispectral imaging techniques that reveal previously hidden details. These advancements have found applications in fields such as art conservation, document analysis, and even medical imaging. The ongoing debate surrounding the shroud has also fostered interdisciplinary collaboration, bringing together experts from diverse fields such as physics, chemistry, biology, and computer science. This collaborative approach has led to innovative problem-solving methods that benefit scientific research across multiple disciplines. The lost city of Heraklion was an ancient Egyptian port city that vanished beneath the Mediterranean Sea over 1,000 years ago. Located near the canopic mouth of the Nile, it served as a crucial gateway to Egypt for Greek and other foreign traders. For centuries, Heraklion was believed to be nothing more than a legend, its existence known only through scattered mentions in ancient texts. In 2001, marine archaeologists made an astounding discovery. They found the submerged ruins of Heraklion just off the coast of modern-day Alexandria. The city lay hidden under 30 to 150 feet of water, preserved in remarkable condition due to the protective layers of sand and mud that had covered it for centuries. Explorers uncovered a treasure trove of artifacts, including massive statues, intricate jewelry, and ritual objects. They also found the remains of over 60 ships, numerous gold coins, and stone slabs with ancient Greek and Egyptian inscriptions. These findings have provided invaluable insights into the city's importance as a center of trade and religious activity. The discovery of Heraklion has revolutionized our understanding of ancient Egyptian maritime history and trade relations. It serves as a powerful reminder that even seemingly lost cities can resurface, offering us glimpses into long-forgotten worlds and reshaping our knowledge of the past. The ancient Egyptian city of Heraklion was rediscovered in the year 2000. French archaeologist Franck Gaudiot and his team made this remarkable find after years of searching the Mediterranean seabed near Alexandria. Using advanced sonar technology and other sophisticated equipment, they located the sunken city that had been lost to the world for over 1,000 years. Heraklion, also known as Thonis to the ancient Egyptians, was once a thriving port city at the mouth of the Nile River. It served as a crucial gateway for trade between Egypt and the Mediterranean world. The city's rediscovery has provided archaeologists with a wealth of information about ancient Egyptian life, trade, and religious practices. Since its rediscovery, numerous artifacts have been excavated from the underwater site, including massive statues, intricate jewelry, and well-preserved religious objects. These findings have shed new light on the city's importance and the daily lives of its inhabitants. The discovery of Heraklion has been hailed as one of the most significant archaeological finds of the 21st century, offering a unique glimpse into a long-lost world beneath the waves. The discovery and mapping of Heraklion, the ancient Egyptian city submerged beneath the Mediterranean Sea, involved a combination of advanced technologies and traditional archaeological methods. Sonar technology played a crucial role in initially locating the site. Using sound waves, researchers were able to create detailed maps of the seafloor, revealing the outlines of structures and artifacts hidden beneath the waves. Once the general location was established, archaeologists employed more precise tools for detailed exploration. Remote sensing techniques, including side-scan sonar and multi-beam echo sounders, provided high-resolution images of the underwater landscape. These technologies allowed researchers to identify specific buildings, statues, and other significant features without disturbing the site. Magnetometry was another key technology used in mapping Heraklion. This method detects variations in the Earth's magnetic field caused by buried objects, helping archaeologists locate metal artifacts and structures beneath layers of sediment. Additionally, sub-bottom profilers were utilized to penetrate the seabed and reveal buried structures and artifacts. The final stage of mapping involved underwater excavation and documentation. Divers used underwater cameras and photogrammetry techniques to create three-dimensional models of the site. This comprehensive approach, combining cutting-edge technology with traditional archaeological practices, has allowed researchers to piece together a detailed picture of this long-lost city and its rich history. Heraklion, the ancient Egyptian city rediscovered beneath the Mediterranean Sea, has revealed a wealth of unique architectural features. One of the most striking discoveries is the vast network of canals that crisscrossed the city, suggesting a Venice-like structure where boats were the primary mode of transportation. These canals were lined with hundreds of anchors, attesting to the city's importance as a major port. The city's temples showcase a fascinating blend of Egyptian and Greek architectural styles, reflecting its multicultural nature. The Temple of Amun-Gereb, the city's main temple, stands out with its massive stone columns and intricate carvings. Archaeologists have also uncovered numerous statues, including a colossal 16-foot statue of a Ptolemaic king, which once stood at the temple's entrance. Another remarkable feature is the presence of underwater stone slabs inscribed with ancient Greek and Egyptian texts. These slabs, known as stelae, provide valuable insights into the city's laws, customs, and religious practices. The discovery of over 700 ancient anchors and 64 ancient shipwrecks in the surrounding waters further emphasizes Heraklion's significance as a maritime hub. The city's submerged ruins also include well-preserved dwellings, showing advanced urban planning with distinct residential districts. The presence of workshops, import warehouses, and intricate harbor installations paints a picture of a thriving economic center that played a crucial role in ancient Mediterranean trade networks. The ancient Egyptians did not construct a city specifically designed to withstand submersion. However, the legendary city of Heraklion, also known as Thonis, provides an intriguing example of an ancient Egyptian city that remained hidden beneath the waters of the Mediterranean Sea for over 1,000 years. Heraklion was built on the Nile Delta, near the mouth of the river where it meets the Mediterranean. The city was not intentionally constructed to be submerged, but rather fell victim to a combination of natural phenomena. Gradual sea level rise, coupled with the slow sinking of the land due to the compaction of soft delta sediments, led to the city's eventual submergence. The structures of Heraklion were primarily built using limestone blocks, a material commonly used in ancient Egyptian construction. While not specifically designed for underwater preservation, limestone's durability allowed many structures to survive centuries of submersion. The city's layout, with its network of canals and harbors, inadvertently helped preserve some structures by creating pockets of stability in the underwater environment. Archaeologists have discovered remarkably well-preserved artifacts, including enormous statues, intricate jewelry, and even shipwrecks in the submerged ruins of Heraklion. These findings offer a unique glimpse into the daily life and architecture of this ancient Egyptian port city, frozen in time by the sea that claimed it. The sunken city of Heraklion, rediscovered off the coast of Egypt in 2000, has yielded a treasure trove of artifacts that shed light on ancient Egyptian technology. Among the most significant finds are large stone blocks with intricate carvings and hieroglyphs, which demonstrate advanced stone cutting and engraving techniques. These blocks, some weighing several tons, reveal the Egyptians' mastery of moving and positioning massive objects with precision. Numerous bronze statues recovered from the site showcase the sophisticated metalworking skills of ancient Egyptian artisans. These statues, remarkably well preserved due to the underwater environment, display intricate details and complex casting techniques that were far ahead of their time. The quality of these artifacts suggests a highly developed understanding of metallurgy and artistic craftsmanship. Maritime technology is another area where Heraklion has provided valuable insights. The discovery of ship anchors, navigational tools, and remnants of ancient vessels offers a glimpse into the advanced seafaring capabilities of the Egyptians. These findings indicate that they possessed considerable knowledge of shipbuilding, maritime trade, and navigation, which allowed them to establish Heraklion as a major port city. Additionally, the excavation of Heraklion has unearthed various tools and everyday objects that illuminate the technological prowess of ancient Egyptians in fields such as agriculture, fishing, and textile production. These artifacts, ranging from farming implements to fishing nets and weaving tools, demonstrate the ingenuity and practical problem-solving skills that characterized Egyptian civilization in its heyday. Underwater archaeology has undergone remarkable advancements in recent decades, revolutionizing our ability to explore and study submerged sites like the ancient Egyptian city of Heraklion. Modern technology has played a crucial role in this evolution, enabling archaeologists to map, excavate, and analyze underwater sites with unprecedented precision and efficiency. Sonar technology has become an indispensable tool for underwater archaeologists. Advanced side-scan sonar systems can now create detailed maps of the seafloor, revealing the outlines of sunken structures and artifacts. This allows researchers to identify promising areas for investigation before even entering the water. In the case of Heraklion, sonar surveys helped archaeologists locate the city's remains and plan their excavation strategy. Underwater robotics have also transformed the field. Remotely operated vehicles equipped with high-definition cameras and robotic arms can now explore depths that were once inaccessible to human divers. These robots can capture detailed imagery, take samples, and even assist in the careful excavation of delicate artifacts. At Heraklion, such technology has allowed archaeologists to study intricate temple structures and recover well-preserved statues from the seabed. Advancements in diving equipment and techniques have greatly extended the time archaeologists can spend underwater. Specialized mixed-gas breathing systems and heated suits allow divers to work at greater depths for longer periods, increasing the scope and detail of their investigations. This has been particularly valuable at sites like Heraklion, where extensive underwater surveys and meticulous excavation work are required to piece together the city's history and layout. The ancient Egyptian city of Heraklion, also known as Thonis, vanished beneath the Mediterranean Sea over 1,000 years ago. Several theories attempt to explain its sudden submersion. One prominent hypothesis suggests that the weight of massive stone structures on the city's unstable foundation of waterlogged clay and sand led to soil liquefaction. This process occurs when saturated soil loses its strength, causing buildings to sink. Another theory points to a catastrophic event, such as an earthquake or tsunami, that might have struck the region. The Nile Delta, where Heraklion was located, is seismically active, and a powerful tremor could have triggered widespread collapse and flooding. Some researchers propose that a combination of gradual subsidence and a sudden natural disaster sealed the city's fate. Climate change and rising sea levels also play a role in many theories about Heraclean submersion. As global temperatures increased following the last ice age, melting glaciers caused sea levels to rise, potentially overwhelming the low-lying coastal city. This gradual process, combined with the Nile Delta's natural subsidence, may have slowly inundated Heraklion over time. Lastly, some experts suggest human activity contributed to the city's demise. Intensive agriculture and irrigation in the surrounding areas could have altered the local hydrology, potentially destabilizing the ground beneath Heraklion. The construction of canals and the diversion of water sources might have exacerbated natural processes, ultimately leading to the city's submersion. The Voynich manuscript is one of the most perplexing and enigmatic documents in history. Dating back to the early 15th century, this mysterious tome has confounded scholars, cryptographers, and historians for centuries. Named after Wilfrid Voynich, the Polish book dealer who acquired it in 1912, the manuscript consists of approximately 240 vellum pages filled with bizarre illustrations and an indecipherable script. The content of the Voynich manuscript appears to cover a wide range of subjects, including botany, astronomy, biology, and possibly medicine. Its pages are adorned with intricate drawings of unknown plants, celestial diagrams, and peculiar human figures. However, the true meaning behind these illustrations remains elusive due to the uncrackable code in which the text is written. Numerous attempts have been made to decipher the Voynich manuscript using various cryptographic techniques and linguistic analyses. Some experts believe it to be an elaborate hoax, while others argue it contains genuine, encrypted knowledge. Carbon dating has confirmed its age, but the identity of its author and the purpose of its creation continue to elude researchers. The Voynich manuscript currently resides in the Beinecke Rare Book and Manuscript Library at Yale University, where it continues to captivate the imagination of scholars and enthusiasts alike. Its enduring mystery serves as a testament to the complexity of human knowledge and the allure of unsolved historical puzzles. The Voynich manuscript remains one of the most enigmatic documents in history, shrouded in mystery and intrigue. While its exact origins are still debated, most experts believe it was created in the early 15th century, likely between 1400 and 1430. This time frame is primarily based on radiocarbon dating of the vellum pages, which has provided the most concrete evidence for the manuscript's age. The manuscript's peculiar illustrations and undeciphered text have fueled countless theories about its creation and purpose. Some scholars have suggested it might be older, possibly dating back to the 13th century, while others propose it could be a more recent fabrication. However, the scientific analysis of the materials used in the manuscript strongly supports the early 15th century date. Interestingly, the manuscript's history becomes clearer only from the 17th century onward, when it was acquired by Georg Baresch, an alchemist from Prague. This gap in provenance has led to speculation about the manuscript's journey and ownership during the intervening years. Despite numerous attempts by cryptographers, linguists, and computer scientists, the text of the Voynich manuscript remains unreadable, adding to its allure and the ongoing debate about its origins. The creation of the Voynich manuscript coincides with a period of significant intellectual and cultural change in Europe, including advancements in alchemy, early scientific thought, and the cusp of the Renaissance. This context has led some researchers to view the manuscript as a product of its time, possibly reflecting the esoteric knowledge and practices of the late medieval period. The Voynich manuscript's writing system stands out as one of the most perplexing and unique scripts ever discovered. This mysterious text, dating back to the early 15th century, has confounded scholars and cryptographers for centuries due to its unparalleled nature. What sets the Voynich script apart is its complete indecipherability. Unlike other historical scripts that have been cracked over time, the Voynich manuscript's writing system remains entirely unreadable. It consists of a series of elegant, flowing characters that bear some resemblance to European alphabets, but do not correspond to any known language or code. The script exhibits several unusual features that contribute to its enigmatic status. It appears to follow consistent patterns and structures, suggesting it represents a genuine language or code rather than random markings. However, statistical analyses have revealed that the text has properties unlike any known natural language, such as an unusually high level of repetition and a curious lack of certain expected linguistic features. Adding to its uniqueness, the manuscript contains no corrections or errors, which is highly unusual for a handwritten document of its length. This peculiarity has led some researchers to speculate about the nature of its creation and purpose, further deepening the mystery surrounding this extraordinary writing system. The Voynich manuscript contains a fascinating array of illustrations that have puzzled researchers for centuries. These images cover a wide range of subjects, adding to the enigma of this mysterious text. The manuscript features numerous botanical illustrations depicting plants that often defy identification by modern botanists. Some of these plant drawings show roots, leaves, and flowers in intricate detail, while others seem to be entirely fantastical or composite creations. Another prominent category of illustrations in the Voynich manuscript is astronomical and astrological in nature. These include circular diagrams resembling zodiac wheels, as well as drawings that appear to represent celestial bodies and constellations. Some pages display what look like naked female figures immersed in strange, tube-like structures or vessels filled with liquid, often interpreted as being related to medieval bathing or alchemical practices. The manuscript also contains maps or cosmological diagrams with rosette-like patterns, which some scholars believe might represent geographical information or symbolic representations of the universe. Additionally, there are illustrations that seem to depict microscopic structures, although it is unclear whether these are based on actual observations or purely imaginative creations. Throughout the manuscript, these diverse illustrations are interwoven with the indecipherable text, creating a visual tapestry that continues to captivate and confound experts across various fields of study. The unique nature of these images, combined with the unreadable text, has fueled countless theories about the manuscript's origin and purpose, making it one of the most intriguing unsolved mysteries in the world of historical documents. Modern cryptography has brought new tools and techniques to bear on the enigmatic Voynich manuscript, a mysterious medieval text that has confounded scholars for centuries. Researchers have employed advanced statistical analysis and machine learning algorithms to search for patterns and structures within the manuscript's unusual script and illustrations. One approach has involved using computer programs to analyze the frequency and distribution of symbols in the text, comparing them to known languages and codes. This method aims to identify any underlying linguistic or mathematical patterns that might reveal clues about the manuscript's origins or meaning. Another technique has focused on applying natural language processing models to the text, attempting to identify word-like units and grammatical structures. Some researchers have even used artificial intelligence systems trained on multiple languages to try and detect similarities between the Voynich script and known writing systems. Despite these advanced efforts, the Voynich manuscript continues to resist decryption. While modern cryptography has provided new insights into the text's structure and complexity, it has yet to yield a definitive breakthrough in understanding its contents or purpose. The manuscript remains one of the most intriguing, unsolved puzzles in the field of historical cryptography. The Voynich manuscript remains one of the most perplexing enigmas in the world of historical documents. This mysterious book, dating back to the early 15th century, has baffled scholars and cryptographers for centuries with its indecipherable text and bizarre illustrations. Several theories attempt to explain the origin and purpose of this cryptic tome. One prominent idea suggests that the manuscript is an elaborate hoax, possibly created by medieval con artists to deceive wealthy collectors. Proponents of this theory argue that the text's resistance to decryption and the fantastical nature of its illustrations point to a deliberate attempt to confuse and mystify. Another theory proposes that the Voynich manuscript is a genuine work of esoteric knowledge, possibly related to alchemy, herbal medicine, or forgotten spiritual practices. Supporters of this view point to the detailed botanical drawings and what appear to be astronomical charts as evidence of a coherent, if obscure, system of knowledge. Some researchers speculate that the manuscript might be the work of an unknown civilization or a lost language. This theory, while less mainstream, is fueled by the unique characteristics of the text and the inability to link it conclusively to any known writing system. Regardless of its true nature, the Voynich manuscript continues to captivate imaginations and challenge our understanding of medieval scholarship and cryptography. Spectral imaging has provided valuable insights into the enigmatic Voynich manuscript, shedding light on its composition and history. This advanced technique allows researchers to examine the document across different wavelengths of light, revealing details invisible to the naked eye. By using spectral imaging, scientists have been able to analyze the inks and pigments used in the manuscript. This has helped determine that the text and illustrations were likely created in the early 15th century, supporting the carbon dating results of the parchment. The imaging has also revealed that the manuscript was written with iron gall ink, a common writing medium of the time. One of the most intriguing discoveries made through spectral imaging is the presence of hidden text and corrections. In some areas of the manuscript, researchers have found evidence of erased or overwritten content, suggesting that the document underwent revisions or edits. This finding challenges the notion that the manuscript was written in a single, continuous effort. Furthermore, spectral imaging has helped identify different hands in the creation of the manuscript. By examining the subtle variations in ink composition and application, researchers have found evidence that multiple individuals may have contributed to its writing and illustration. This insight adds another layer of complexity to the already mysterious nature of the Voynich manuscript, deepening our understanding of its origins and purpose. The Voynich manuscript, an enigmatic book from the 15th century, continues to intrigue scholars and enthusiasts alike with its potential insights into medieval science and technology. This mysterious tome, filled with strange illustrations and an undeciphered script, offers tantalizing glimpses into the scientific knowledge and technological capabilities of its time. The manuscript's botanical illustrations suggest a deep interest in herbal medicine and plant lore, reflecting the medieval approach to healthcare and pharmacology. These detailed drawings might represent known plants or potentially undiscovered species, hinting at a broader understanding of botany than previously thought for that era. The astronomical and cosmological diagrams in the manuscript could indicate advanced knowledge of celestial observations and theories, possibly challenging our current understanding of medieval astronomy. Alchemical symbolism present in the Voynich manuscript points to the period's fascination with transformative processes and the quest for the philosopher's stone. This aspect of the document might shed light on early chemical experiments and the foundations of modern chemistry. The presence of what appear to be mechanical diagrams could suggest more sophisticated technological knowledge than typically attributed to the Middle Ages, potentially revealing lost inventions or engineering concepts. While the true nature and content of the Voynich manuscript remain a mystery, its very existence and complexity challenge our perceptions of medieval scientific and technological capabilities. It serves as a reminder that the medieval period was not simply a dark age, but a time of curiosity, exploration, and potentially groundbreaking ideas that were ahead of their time. The Quimbaya artifacts are a collection of intriguing pre-Columbian objects discovered in Colombia, South America. These artifacts, dating back to around 1000 CE, were crafted by the Quimbaya civilization, a sophisticated indigenous culture known for their exceptional metalworking skills. The most famous and controversial of these artifacts are small golden figurines that bear a striking resemblance to modern aircraft. These objects, often referred to as the Quimbaya airplanes, feature delta wing shapes, tail fins, and even what appear to be cockpits. This uncanny similarity to contemporary flying machines has sparked intense debate and speculation among researchers and enthusiasts. While some interpret these figurines as evidence of advanced ancient technology or even extraterrestrial contact, most archaeologists and historians view them as stylized representations of native birds, insects, or mythical creatures. The Quimbaya were known for their naturalistic animal depictions, and these objects likely reflect their artistic interpretations of the natural world. Beyond the controversial airplane-like figurines, the Quimbaya artifacts include an array of beautifully crafted gold and copper objects. These range from intricate jewelry and ceremonial items to elaborate containers and anthropomorphic figures, all showcasing the remarkable metallurgical expertise of this ancient civilization. The Quimbaya artifacts were created during the pre-Columbian era in what is now Colombia, South America. These remarkable objects date back to a period between approximately 500 and 1,500 years ago. The Quimbaya civilization flourished in the Middle Cauca River Valley, producing an array of intricate gold and copper alloy objects that have captivated archaeologists and art enthusiasts alike. These artifacts showcase the exceptional metalworking skills of the Quimbaya people, demonstrating their mastery of lost wax casting techniques. The collection includes a wide variety of items, from ceremonial objects and jewelry to everyday utensils. Perhaps the most famous among these are the Quimbaya figurines, small golden statues that depict stylized human forms with distinct features and elaborate headdresses. Interestingly, some of the Quimbaya artifacts have sparked controversy and speculation due to their resemblance to modern aircraft. These particular objects, often referred to as the Quimbaya airplanes, have led some fringe theorists to suggest advanced ancient technology or extraterrestrial influence. However, mainstream archaeologists interpret these items as stylized representations of birds, insects, or mythological creatures, firmly rooted in the cultural context of the Quimbaya civilization. The precise dating of individual Quimbaya artifacts can be challenging, as many were looted from archaeological sites before proper excavation could take place. Nevertheless, ongoing research continues to shed light on the chronology and cultural significance of these fascinating pre-Columbian treasures. The Quimbaya artifacts, renowned for their intricate designs and exceptional craftsmanship, were primarily crafted from gold and gold alloys. These pre-Columbian objects, created by the Quimbaya civilization in what is now Colombia, showcase the advanced metalworking skills of ancient South American cultures. Artisans used a technique called lost wax casting to create many of these artifacts. This method allowed for the production of complex, detailed forms with hollow interiors. The process involved creating a wax model, covering it with clay, and then melting out the wax to leave a mold for pouring molten metal. In addition to pure gold, the Quimbaya metalworkers often employed tumbaga, an alloy of gold and copper. This combination provided a more durable material while maintaining the desired golden appearance. The proportion of gold to copper in tumbaga could be adjusted to achieve different colors and properties. Some Quimbaya artifacts also incorporate other materials such as precious stones, particularly emeralds, which were highly valued in pre-Columbian cultures. These additional elements further enhanced the beauty and significance of these remarkable objects, which continue to captivate archaeologists and art enthusiasts alike. Some Quimbaya artifacts have sparked intense debate due to their unusual shapes that bear a striking resemblance to modern aircraft. These golden objects, created by the Quimbaya civilization in what is now Colombia, date back to around 500 to 1,000 years ago. The artifacts feature delta wing shapes, tail fins, and even what appear to be stabilizers, elements commonly found in contemporary airplane design. This resemblance has led some researchers and ancient astronaut theorists to speculate that the Quimbaya might have had knowledge of advanced aeronautics or even witnessed extraterrestrial craft. They argue that these artifacts could be representations of flying machines far beyond the technological capabilities of pre-Columbian civilizations. However, mainstream archaeologists and historians offer a more grounded explanation. They suggest that these artifacts are stylized representations of local wildlife, particularly fish and birds. The triangular shapes could be interpreted as bird beaks or fish bodies, while the protruding elements might represent fins or wings. This interpretation aligns with the known artistic traditions and cultural context of the Quimbaya people. It is important to note that no evidence of actual flying machines or advanced aeronautical knowledge has been found in Quimbaya archaeological sites. The debate surrounding these artifacts highlights the human tendency to seek familiar patterns in ancient objects and the ongoing fascination with the possibility of advanced ancient technologies. The Quimbaya artifacts, small golden objects from pre-Columbian Colombia, have sparked debate due to their resemblance to modern aircraft. While some enthusiasts claim these are evidence of ancient advanced technology or extraterrestrial contact, archaeologists and historians offer more grounded explanations. Most experts interpret these objects as stylized representations of native animals, particularly birds and insects. The elongated bodies and wing-like protrusions align with artistic depictions of various flying creatures found in nature. Some suggest they might represent specific species like birds of prey or large insects common to the region. Another interpretation views these artifacts as abstract, religious, or ceremonial objects. Many pre-Columbian cultures created symbolic items for rituals or as status symbols, often incorporating natural elements into their designs. The unusual shapes could be artistic expressions of spiritual concepts rather than literal depictions of flying machines. It is also worth considering that our modern perspective might influence how we perceive these ancient objects. The similarity to aircraft could be a case of pareidolia, where we see familiar patterns in unrelated objects. This phenomenon often leads to misinterpretations of ancient artifacts through a contemporary lens. Aerodynamic testing of ancient artifact replicas has provided fascinating insights into their potential flight capabilities. Scientists and researchers have used wind tunnels and computer simulations to study how these objects might have behaved in the air. For example, replicas of the Saqqara bird, an ancient Egyptian wooden carving, have been subjected to wind tunnel tests. These experiments revealed that with slight modifications, the artifact could indeed generate lift, suggesting it might have been an early attempt at modeling flight. Similar tests have been conducted on reproductions of gold figurines found in South America, often referred to as golden flyers. When placed in wind tunnels, these replicas demonstrated surprising stability and lift generation, characteristics typically associated with modern aircraft designs. Computational fluid dynamics simulations have also been employed to analyze the potential aerodynamic properties of these ancient objects, allowing researchers to study their behavior under various conditions without the need for physical models. These aerodynamic tests serve a dual purpose. They not only help us understand the potential capabilities of these artifacts, but also provide insights into the knowledge and technological sophistication of ancient civilizations. By combining traditional archaeological methods with modern engineering techniques, researchers can paint a more comprehensive picture of our ancestors' understanding of flight and aerodynamics. However, it is important to note that while these tests yield intriguing results, they do not definitively prove that the original artifacts were intended for flight. The findings open up new avenues for interpretation and discussion about the purpose and significance of these ancient objects in their respective cultures. The Quimbaya artifacts continue to intrigue researchers with their potential implications for advanced technological knowledge in pre-Columbian South America. These golden objects, particularly the famous Quimbaya airplanes, have sparked debates about the extent of ancient engineering capabilities. Beyond the controversial aircraft-like figurines, other Quimbaya artifacts showcase sophisticated metalworking techniques. The gold alloys used in these objects demonstrate a deep understanding of metallurgy, with precise combinations of gold, copper, and other metals to achieve desired properties and colors. This mastery over metals suggests a level of scientific knowledge that was quite advanced for its time. Some researchers have pointed out that certain Quimbaya objects bear resemblance to modern technological devices, though these interpretations remain highly speculative. The precision and complexity of the designs, however, do indicate a sophisticated grasp of geometry and three-dimensional modeling. While it is important to approach these artifacts with scientific skepticism, they undoubtedly reveal that the Quimbaya culture possessed significant technological capabilities. The full extent of their knowledge remains a subject of ongoing study and debate among archaeologists and historians. The Quimbaya artifacts discovered in Colombia have sparked intense debate among archaeologists and historians. These intricate gold objects, created by the Quimbaya civilization between 500 and 1,500 years ago, showcase a level of metallurgical skill that was previously thought to be beyond the capabilities of pre-Columbian societies. What makes these artifacts particularly intriguing is their resemblance to modern aircraft. Some of the golden figurines feature delta wing shapes, tail fins, and even what appear to be cockpits, leading some researchers to suggest they might represent advanced flying machines. This interpretation challenges our conventional understanding of pre-Columbian technology and has led to speculation about the possibility of ancient contact with more technologically advanced civilizations. However, mainstream archaeologists generally interpret these objects as stylized representations of native birds and insects, arguing that their aircraft-like appearance is coincidental. Regardless of their intended representation, the Quimbaya artifacts undeniably demonstrate sophisticated metalworking techniques, including lost wax casting and gold alloying, which were remarkably advanced for their time. The precision and complexity of these golden objects force us to reconsider the technological capabilities of ancient American cultures. They remind us that our understanding of past civilizations is continually evolving, and that we must remain open to new interpretations as we uncover more evidence of their achievements. The Nimrud lens is a remarkable artifact discovered in 1950 at the ancient Assyrian city of Nimrud, located in present-day Iraq. This small, oval-shaped piece of rock crystal dates back to the 8th century before Common Era, making it over 2,700 years old. What makes this object particularly intriguing is its carefully worked shape, which resembles a modern plano-convex lens. Measuring about 1.5 inches in length and slightly over an inch in width, the Nimrud lens has a focal point that suggests it could have been used as a magnifying glass or a burning glass to start fires. Some researchers have even proposed that it might have been part of a telescope, though this theory remains highly speculative and controversial. The discovery of the Nimrud lens has sparked debates about the level of optical knowledge possessed by ancient civilizations. While some experts argue that it was intentionally crafted as a lens, others suggest it might have been a decorative item or part of a piece of jewelry. Regardless of its original purpose, the Nimrud lens stands as a testament to the advanced craftsmanship of ancient Assyrian artisans. This ancient artifact challenges our understanding of early scientific knowledge and technological capabilities. It serves as a reminder that ancient civilizations may have possessed more sophisticated tools and understanding than we often give them credit for, prompting us to reconsider our assumptions about the development of human knowledge and technology throughout history. The Nimrud lens was discovered in 1853 during excavations at the ancient Assyrian city of Nimrud, located in modern-day Iraq. British archaeologist Sir John Layard unearthed this intriguing artifact while exploring the ruins of the Northwest Palace, a structure dating back to the 8th century before Common Era. This small yet significant object, made of rock crystal, immediately caught the attention of researchers due to its unusual shape and potential optical properties. Measuring about 1.5 inches in diameter, the lens-like object sparked debates about its true purpose and the level of scientific knowledge possessed by ancient Mesopotamian civilizations. The discovery of the Nimrud lens opened up new avenues of inquiry into the technological capabilities of ancient societies. Its existence raised questions about whether the Assyrians had developed rudimentary optical instruments, potentially for astronomical observations or other scientific purposes. This find challenged preconceptions about the development of optical technology in the ancient world. Since its discovery, the Nimrud lens has been housed in the British Museum in London, where it continues to intrigue scholars and visitors alike. Its presence in the museum collection serves as a testament to the enduring mystery and fascination surrounding ancient technological achievements. The Nimrud lens is an ancient artifact crafted from rock crystal, also known as quartz. This remarkable object was discovered in 1853 during excavations at the Assyrian Palace of Nimrud, located in what is now modern-day Iraq. The lens is a plano-convex piece, meaning it has one flat side and one convex or outwardly curved side. Rock crystal, the material from which the Nimrud lens is fashioned, is a naturally occurring, transparent form of quartz. This mineral is known for its clarity and durability, making it an ideal choice for optical instruments. The ancient craftsmen who created this lens demonstrated remarkable skill in shaping and polishing the hard quartz crystal into a functional optical device. The use of rock crystal for the Nimrud lens is significant because it showcases the advanced knowledge and technological capabilities of ancient Mesopotamian civilizations. This material choice allowed for the creation of a lens with optical properties that could potentially magnify or focus light, suggesting a sophisticated understanding of optics in the ancient world. While the exact purpose of the Nimrud lens remains a subject of debate among archaeologists and historians, its composition of rock crystal undoubtedly contributes to its enduring fascination and historical importance. This ancient quartz lens continues to captivate researchers and the public alike, offering a tangible link to the scientific and technological achievements of our ancestors. The Nimrud lens, an ancient artifact discovered in Iraq, possesses remarkable optical properties that have intrigued scientists and historians alike. This small piece of rock crystal, dating back to the 7th or 8th century before Common Era, exhibits a plano-convex shape characteristic of a magnifying lens. When examined closely, the Nimrud lens demonstrates the ability to focus light and produce magnified images. Its curved surface allows it to concentrate light rays to a focal point, potentially enabling it to function as a primitive magnifying glass or burning glass. The lens has a focal length of approximately 11 centimeters, suggesting it could have been used to magnify small objects or text. Interestingly, the Nimrud lens shows signs of deliberate grinding and polishing, indicating that its creators possessed knowledge of optics and lens-making techniques. The quality of its craftsmanship is surprisingly high for its age, with a relatively smooth surface that enhances its optical performance. Despite its ancient origins, the Nimrud lens exhibits optical properties comparable to modern-day lenses, sparking debates about the level of scientific understanding in ancient Mesopotamian civilizations. Its existence raises questions about the potential applications of such technology in fields like astronomy, craftsmanship, or even early attempts at correcting vision impairments in the ancient world. The Nimrud lens, a remarkable artifact discovered in modern-day Iraq, is estimated to be around 2,800 years old. This ancient piece of rock crystal was unearthed during excavations at the Assyrian Palace of Nimrud, which flourished between 900 and 750 BCE. The lens dates back to the Neo-Assyrian period, a time when the Assyrian Empire was at its peak of power and influence in the ancient Near East. Archaeologists and historians have debated the exact purpose of the Nimrud lens since its discovery. Some experts suggest it might have been used as a magnifying glass or a burning glass to start fires. Others propose it could have been part of a telescope or other optical instrument, potentially indicating that ancient civilizations had more advanced scientific knowledge than previously thought. The existence of such a precisely crafted optical tool from this period challenges our understanding of ancient technological capabilities. It raises intriguing questions about the level of scientific understanding and craftsmanship in Assyrian society. The Nimrud lens serves as a testament to the ingenuity and skill of ancient artisans, demonstrating that sophisticated optical technology existed long before the formal development of modern optics. The Nimrud lens, discovered in Iraq in 1853, has sparked numerous theories about its purpose and significance. This ancient rock crystal artifact, dating back to the 7th century BCE, has intrigued archaeologists and historians for generations. One prominent theory suggests that the Nimrud lens served as a magnifying glass for intricate craftsmanship. Ancient Assyrian artisans might have used it to create detailed carvings and jewelry, enhancing their ability to work on small, delicate objects. This theory aligns with the known sophistication of Assyrian craftsmanship during that period. Another hypothesis proposes that the lens was part of a telescope or other optical instrument. Some researchers argue that ancient civilizations might have possessed more advanced astronomical knowledge than previously thought. However, this theory remains controversial, as there is limited evidence to support the existence of such complex optical devices in the ancient Near East. A third theory considers the Nimrud lens as a decorative or ritualistic object. It may have been used to focus light or fire for religious ceremonies, or simply admired for its unique optical properties. The lens's placement among other valuable items in the ruins of the Assyrian palace at Nimrud lends credence to its potential ceremonial or ornamental role. The Nimrud lens, discovered in modern-day Iraq, has sparked intriguing discussions about ancient astronomical practices. This rock crystal artifact, dating back to the 7th or 8th century BCE, possesses optical properties that have led some researchers to consider its potential use in early stargazing efforts. While its exact purpose remains debated, the Nimrud lens could have served as a rudimentary magnifying tool for ancient Mesopotamian astronomers. Its ability to focus light might have allowed observers to discern finer details of celestial bodies, potentially aiding in the tracking of planetary movements or lunar phases. Some scholars speculate that the lens might have been employed in conjunction with other instruments to enhance astronomical observations. For instance, it could have been used to magnify markings on astrolabes or other early astronomical devices, improving the precision of measurements and calculations. However, it is important to note that the astronomical use of the Nimrud lens remains speculative. Alternative theories suggest it might have been a decorative object or used for other purposes entirely. Nonetheless, its existence demonstrates the technological sophistication of ancient civilizations and continues to fuel our curiosity about early astronomical practices. The Nimrud lens, discovered in Iraq in 1853, challenges our perceptions of ancient technological capabilities. This rock crystal artifact, dating back to the 7th or 8th century BCE, exhibits surprising optical properties that have sparked debate among archaeologists and historians of science. With its carefully ground and polished surface, the Nimrud lens demonstrates a level of craftsmanship previously thought beyond the reach of ancient Mesopotamian artisans. Its ability to focus light and magnify objects suggests that the Assyrians may have possessed more advanced optical knowledge than we previously believed. This raises intriguing questions about the potential applications of such technology in ancient times. Some researchers propose that the lens could have been used as a magnifying glass for intricate craftwork, such as the creation of detailed cuneiform tablets or delicate jewelry. Others speculate about its possible use in astronomical observations or as a fire-starting tool. These hypotheses, if substantiated, would require us to reevaluate our understanding of ancient scientific and technological achievements. The existence of the Nimrud lens also prompts us to consider the possibility that other ancient civilizations may have developed similar optical devices that have not yet been discovered or recognized. This underscores the importance of remaining open to new evidence that might reshape our understanding of ancient scientific knowledge and technological capabilities. The Baigong pipes are a series of unusual pipe-like structures found in and around Mount Baigong, located in the Qinghai province of China. These mysterious formations have sparked intense debate among scientists and researchers due to their peculiar nature and uncertain origin. Discovered in the 1990s, the Baigong pipes consist of a network of metallic tubes embedded in the rock face of Mount Baigong and extending into nearby Toson Lake. What makes these pipes particularly intriguing is their apparent sophistication and the fact that they seem to be out of place in an area with no recorded history of industrial activity. The pipes vary in size, with some as small as a toothpick, while others measure up to 40 centimeters in diameter. They appear to be made of iron, though their exact composition remains a subject of scientific inquiry. Some of the pipes run deep into the mountain, while others protrude from the rock face or lie scattered on the ground. Various theories have been proposed to explain the existence of the Baigong pipes. Some researchers suggest they could be the result of natural geological processes, such as iron precipitation in rock fractures. Others speculate about the possibility of an ancient, advanced civilization, or even extraterrestrial involvement. However, conclusive evidence supporting any single explanation remains elusive, leaving the Baigong pipes as one of Earth's enduring geological mysteries. The Baigong pipes are located in China, specifically in the Qinghai province. This remote region lies in the northwestern part of the country, nestled within the rugged landscape of the Tibetan Plateau. The pipes can be found near Mount Baigong, which gives them their name, in an area that is sparsely populated and known for its harsh, arid climate. The site of the Baigong pipes is situated about 40 kilometers southwest of the city of Delingha. This mysterious location features a pyramid-shaped formation on Mount Baigong, which contains 3 caves. 2 of these caves have collapsed and are inaccessible, but the largest one remains open and is where many of the strange pipes can be observed. Surrounding the mountain, more pipes can be found protruding from the ground and along the shores of nearby Lake Toson, also known as Alien Lake, due to its connection with the enigmatic pipes. The pipes extend into the lake itself, with some reportedly visible beneath the water's surface. This remote location adds to the intrigue surrounding the Baigong pipes, as their presence in such an isolated and seemingly inhospitable environment raises questions about their origin and purpose. The difficult access and harsh conditions of the area have contributed to the limited scientific study of these unusual formations. The Baigong pipes, located in China's Qinghai province, have puzzled scientists for decades. These mysterious structures are primarily composed of iron, with traces of other elements, such as silicon and calcium. Analysis of the pipes has revealed that they contain a mixture of iron oxides, suggesting exposure to oxidation over time. Interestingly, the iron content of the pipes is unusually high, reaching up to 95% in some samples. This composition has led to speculation about their origin, with some researchers proposing that they might be fossilized tree roots or even evidence of ancient advanced technology. However, recent studies have shown that the pipes likely formed through natural geological processes. The iron-rich sediment in the area, combined with groundwater movement and mineral deposition, could have created these pipe-like structures over millions of years. This process, known as pseudo-karst formation, can result in remarkably uniform and seemingly artificial structures. Despite their natural origin, the Baigong pipes continue to captivate scientists and enthusiasts alike, serving as a reminder of the complex and often surprising ways in which geological processes can mimic human engineering. Their unique composition and formation highlight the fascinating interplay between iron-rich environments and natural forces over vast periods of time. The Baigong pipes, discovered in China's Qinghai province, have been a subject of intense scientific debate and speculation. Estimates of their age vary widely, with some researchers suggesting they could be as old as 150,000 years. However, this extreme age estimate is highly controversial and not widely accepted in the scientific community. More conservative estimates place the age of the Baigong pipes at around 5,000 years old, potentially linking them to ancient Chinese civilizations. This time frame aligns more closely with known human technological capabilities and the development of metalworking in the region. The difficulty in precisely dating the pipes stems from their unusual composition and the challenging environment in which they're found. The pipes contain a mix of organic and inorganic materials, complicating traditional dating methods. Additionally, the pipe's location within and around Mount Baigong, a region with significant geological activity, has led some to suggest they might be the result of natural processes rather than human creation. Ongoing research and analysis continue to refine our understanding of the Baigong pipe's origins and age. As new dating techniques emerge and more comprehensive studies are conducted, we may gain a clearer picture of when these enigmatic structures came into existence. The Baigong pipes, discovered in China's Qinghai province, have puzzled scientists and sparked numerous theories about their origin. Some researchers propose that these pipe-like structures are the result of natural geological processes. They suggest that iron-rich magma may have seeped into existing rock formations, creating cylindrical shapes that resemble pipes when exposed by erosion. Another theory posits that the pipes could be fossilized tree roots or other organic matter that has undergone mineralization over millions of years. This explanation accounts for the organic appearance of some of the structures and their seemingly organized layout. More controversial hypotheses suggest artificial origins for the Baigong pipes. Some speculate that they might be remnants of an ancient plumbing system created by an advanced civilization that existed in the region long ago. Others go even further, proposing that the pipes could be evidence of extraterrestrial visitation or technology. Despite these varied theories, the true origin of the Baigong pipes remains uncertain. Scientists continue to study the site, employing advanced dating techniques and geological analysis to unravel the mystery surrounding these enigmatic structures. As research progresses, new insights may emerge, potentially shedding light on this intriguing geological phenomenon. The Baigong pipes, discovered in China's Qinghai province, present a fascinating enigma that challenges our conventional understanding of ancient Chinese technological capabilities. These mysterious structures, embedded in the rock of Mount Baigong, consist of a network of metallic pipes of varying diameters, some as small as a toothpick, while others are large enough for a human to crawl through. What makes the Baigong pipes particularly intriguing is their apparent age and composition. Some scientists estimate that these pipes could be up to 150,000 years old, predating any known metalworking in the region by tens of thousands of years. Analysis of the pipes has revealed that they contain a mixture of metals, including iron, silicon, and aluminum, in proportions that do not occur naturally and would require advanced smelting techniques to produce. The purpose and origin of these pipes remain a subject of intense debate among researchers. Some theories suggest they could be the remnants of an ancient plumbing system, while others propose they might have been used for extraterrestrial communications, or even as part of an early astronomy observatory. The complexity and scale of the pipe network imply a level of engineering and metallurgical knowledge that was not thought to exist in China at such an early date. The Baigong pipes challenge our timeline of technological development in ancient China and raise questions about the potential for advanced civilizations existing far earlier than previously believed. Their existence forces us to reconsider our assumptions about the capabilities of our ancestors and the possibility of lost knowledge or technologies that have yet to be rediscovered. The Baigong pipes, located in China's Qinghai province, have been the subject of several scientific investigations, though comprehensive studies remain limited. Geologists and archaeologists have conducted on-site examinations of these unusual formations, which appear to be pipe-like structures embedded in rock. Analysis of the pipe's composition has revealed a mix of organic and inorganic materials. Some samples contain high percentages of iron oxide, silicon dioxide, and calcium oxide. Interestingly, up to 8% of the material is of unknown origin, prompting further questions about their formation. Radiometric dating techniques have been applied to estimate the age of the pipes, with some results suggesting they could be quite ancient. However, the exact age remains a topic of debate among researchers. Some scientists propose that the pipes might be the result of natural geological processes, such as iron-rich sediments, solidifying into pipe-like shapes over time. While various hypotheses exist about the origin and purpose of the Baigong pipes, including both natural and artificial explanations, more extensive scientific research is needed to reach definitive conclusions. The site continues to intrigue scientists and spark discussions about geological formations and their potential interpretations. The Baigong pipes, located in China's Qinghai province, have puzzled geologists for years. These unusual formations, resembling a network of metallic pipes embedded in rock, have sparked various theories about their origin. Some geologists propose that the pipes are the result of natural geological processes rather than artificial constructions. One leading explanation suggests that the Baigong pipes formed through a process called iron mineralization. This occurs when iron-rich fluids seep through sedimentary rocks, gradually depositing iron minerals in the spaces between sediment grains. Over time, these deposits can create tube-like structures that resemble pipes. Another theory points to the possibility of fossilized tree roots. In this scenario, ancient tree roots would have been replaced by mineral-rich groundwater, preserving their shape as they turn to stone. This process, known as permineralization, can create pipe-like formations that appear metallic due to their mineral content. Some geologists also consider the possibility that the pipes are the result of unique geological conditions combined with erosion. The area's volcanic history and the presence of iron-rich sediments could have created unusual formations that were later exposed and shaped by wind and water erosion, giving them their pipe-like appearance. The Piri Reis map is a fascinating historical artifact that continues to intrigue scholars and enthusiasts alike. Created in 1513 by the Ottoman admiral and cartographer Piri Reis, this map is renowned for its detailed depiction of the Atlantic coastlines of Europe, Africa, and South America. What makes this map particularly remarkable is its inclusion of the Americas, drawn just 2 decades after Christopher Columbus's voyages. Piri Reis claimed to have used about 20 maps and charts as his sources, including some dating back to the time of Alexander the Great. Notably, he also referenced maps used by Christopher Columbus, which no longer exist today. This compilation of various sources resulted in a unique and surprisingly accurate representation of the world for its time. One of the most controversial aspects of the Piri Reis map is its alleged depiction of Antarctica, centuries before the continent was officially discovered. Some researchers argue that the southern coastline shown on the map bears a striking resemblance to the subglacial topography of Antarctica, which was only revealed by modern seismic surveys. However, mainstream scholars generally attribute this to coincidence or misinterpretation. The Piri Reis map stands as a testament to the advanced cartographic knowledge of the early 16th century and the extensive maritime exploration that had already taken place. It continues to spark debates about the extent of ancient seafaring capabilities and the possibility of undocumented voyages to the New World before Columbus. The Piri Reis map was created in the year 1513. This remarkable cartographic artifact was produced by Ottoman admiral and cartographer Piri Reis, whose name it bears. The map is significant not only for its age, but also for its detailed depiction of the Atlantic coastlines of Europe, Africa, and South America. What makes the Piri Reis map particularly intriguing is that it was created just 2 decades after Christopher Columbus first voyaged to the Americas. This timing raises questions about the sources of information available to Piri Reis, as he claimed to have used about 20 maps and charts as references, including some dating back to the time of Alexander the Great. The map showcases the extent of geographical knowledge available in the early 16th century. It combines information from European and Arabic sources, reflecting the confluence of different cartographic traditions. Notably, the map includes details of the Brazilian coast that were supposedly unknown to Europeans at the time, adding to its historical significance and the mystery surrounding its creation. Today, only about 1/3 of the original map survives, preserved in the Topkapi Palace Museum in Istanbul. Despite its fragmentary nature, the Piri Reis map continues to fascinate historians, cartographers, and the public alike, serving as a testament to the advanced state of Ottoman cartography in the early modern period. The Piri Reis map, created in 1513 by Ottoman admiral and cartographer Piri Reis, is a remarkable artifact that continues to intrigue historians and researchers. This fragmented map, which shows portions of the Atlantic coastlines of South America, Africa, and Europe, stands out for several reasons. One of its most striking features is the abhorrent depiction of Antarctica, despite the continent not being officially discovered until 300 years later. The coastline on the map bears a surprising resemblance to the landmass hidden beneath Antarctica's ice sheet, leading to speculation about ancient knowledge of the continent's true shape. The map also showcases an impressive level of accuracy for its time, particularly in its portrayal of South America's eastern coastline. It includes details about the geography of the Americas that were not widely known in Europe during the early 16th century, raising questions about the sources Piri Reis used to compile his work. Another unique aspect of the Piri Reis map is its inclusion of mythical elements alongside geographical features. It depicts legendary creatures, local fauna, and even images of native peoples, providing insight into the blend of fact and folklore that characterized early modern cartography. These elements make the map not just a geographical tool, but a window into the worldview of its time. The Piri Reis map, created in 1513 by Ottoman admiral and cartographer Piri Reis, has long fascinated historians and cartographers due to its surprising accuracy for its time. When compared to modern maps, certain aspects of the Piri Reis map show remarkable precision, while others reflect the limitations of 16th century cartography. The coastlines of Western Africa and Eastern South America are depicted with notable accuracy, considering the map was created just 2 decades after Columbus's voyages. The general shape and positioning of these continents align well with our current understanding. However, the map becomes less accurate as it moves further south, with Antarctica appearing distorted and misplaced. One of the most intriguing features of the Piri Reis map is its depiction of Antarctica, which some claim shows the continent's coastline free of ice. This has led to speculation about ancient knowledge of Antarctica's geography. However, most scholars attribute this to creative interpretation rather than actual mapping of the continent. It's important to note that the Piri Reis map is a compilation of earlier maps, including some dating back to the time of Alexander the Great. This explains both its strengths and limitations when compared to modern cartography. While it captures some geographical features with surprising accuracy, it also incorporates misconceptions and speculative geography common in its era. The Piri Reis map, created in 1512 by Ottoman admiral and cartographer Piri Reis, has sparked significant debate among historians and researchers, particularly regarding its depiction of Antarctica. This controversy centers on the map's southern portion, which some claim shows the coastline of Antarctica with remarkable accuracy, despite the continent not being officially discovered until 300 years later. Proponents of this theory argue that the map's southern coastline closely matches the profile of Antarctica, as it would appear without its ice cover. They suggest this indicates an ancient, advanced civilization possessed knowledge of Antarctica's true geography long before modern exploration. This idea has been used to support various alternative historical narratives and theories about lost civilizations. However, mainstream scholars and cartographers largely reject these claims. They point out that the southern coastline on the Piri Reis map more likely represents a distorted view of South America's coast, possibly combined with speculation about a southern landmass. These experts emphasize that the map's depiction does not accurately match Antarctica's actual coastline, and that any similarities are coincidental or the result of imaginative interpretation. Critics also note that Piri Reis himself stated he based his map on earlier sources, including ancient maps and accounts from contemporary explorers. They argue that the controversial features of the map can be explained through the cartographic techniques and geographical knowledge of the time, without resorting to extraordinary claims about ancient advanced civilizations or knowledge of Antarctica. Ancient cartographers employed a variety of ingenious methods to create surprisingly accurate maps. They relied heavily on astronomical observations, using the positions of stars and the sun to determine latitude and longitude. Skilled navigators would record detailed logs of their voyages, noting landmarks, distances traveled, and the time taken between ports. These logs were then compiled and cross-referenced to build a more comprehensive picture of coastlines and landmasses. Trade routes played a crucial role in map-making, as merchants shared information about distant lands and sea routes. This knowledge was often passed down through generations and combined with new discoveries to refine existing maps. Some cartographers also used mathematical calculations and geometry to estimate distances and shapes of land masses based on available data. Interestingly, ancient civilizations like the Greeks and Phoenicians used sophisticated instruments such as the gnomon, a vertical stick that cast shadows to determine latitude, and the astrolabe, which measured the height of celestial bodies above the horizon. These tools allowed for more precise measurements and improved map accuracy over time. It is worth noting that while some ancient maps were remarkably accurate for their time, they often contained errors and misconceptions. The process of map-making was continually refined as new information became available, and older beliefs were challenged by empirical evidence gathered through exploration and trade. The Piri Reis map, created in 1513 by Ottoman admiral and cartographer Piri Reis, offers intriguing insights into ancient navigation and exploration. This remarkable chart, compiled from various earlier sources, depicts parts of the Americas, Europe, and Africa with surprising accuracy for its time. One of the most striking features of the map is its portrayal of the South American coastline, which some researchers argue shows a level of detail that should not have been possible given the known explorations of that era. This has led to speculation about undocumented voyages or even advanced surveying techniques used by ancient civilizations. The map also includes references to the mythical island of Antikythera and other legendary locations, suggesting that 15th and 16th century explorers still relied on a mix of factual knowledge and folklore in their understanding of world geography. This blend of the real and the imagined provides a fascinating glimpse into the mindset of early modern navigators. Perhaps most intriguingly, some interpretations of the Piri Reis map claim it shows parts of Antarctica free of ice, a condition that supposedly existed millions of years ago. While this idea remains highly controversial, it has fueled debates about the possibility of ancient civilizations possessing sophisticated mapping capabilities or access to much older source materials. Modern technology has revolutionized our ability to analyze and understand historical artifacts like the Piri Reis map. Researchers have employed advanced imaging techniques, including high-resolution digital scanning and multispectral imaging, to examine the map in unprecedented detail. These methods allow experts to see features and markings that are invisible to the naked eye, revealing hidden information about the map's creation and composition. Geographic Information Systems, or GIS, have been crucial in comparing the Piri Reis map to modern cartographic data. By overlaying the historical map with current satellite imagery, researchers can assess its accuracy and identify any discrepancies or unique features. This process has helped verify the remarkable precision of certain coastlines depicted on the map, particularly along South America. Computer modeling and data analysis have also played a significant role in studying the map. These tools allow researchers to account for factors such as changes in coastlines over time due to erosion or sea level fluctuations. By applying these corrections, experts can better understand how the map's depictions relate to both historical and contemporary geography. Radiocarbon dating and chemical analysis of the map's materials have provided insights into its age and origin. These techniques have confirmed the map's creation date in the early 16th century and have helped authenticate its historical significance. Through the application of these modern scientific methods, researchers continue to uncover new information about this fascinating cartographic treasure, shedding light on early exploration and map-making techniques.